welcome to our last workshop of a 2-week Streaming Media Connect. And thank you for joining us. And thank you to Ryan Jesperson from Millicast for putting together a workshop that's going to answer a lot of questions on one of the hottest topics in streaming today. Ryan is going to speak about building the new generation of real-time streaming solutions with WebRTC. And with that, Ryan, I will pass the controls back to you.
Thanks so much, Eric. Hello, everyone. And I'm really excited to talk a little bit about WebRTC. What we're going to focus on today, like Eric mentioned, is building the new, not the next, but the new generation of real-time streaming solutions on WebRTC. So to be engaging, media and video needs to be interactive. But for it to be interactive, for it to enable two-way exchanges between audience and participants, there are these building blocks that you need to have in a streaming solution to enable that interactivity. It needs to be real time. You can't do anything over half a second or a second, or you lose the interactive element of that. It has to be high quality. It can't be web quality or anything lower, because you lose the feeling of things being in person if the quality, both audio and video, are poor. So we need broadcast grade media quality. For it to be truly interactive, we need to be able to embrace the web. We need to be able to get into the domain that allows us to access billions and billions of people around the world. And for it to be web scale, you need to reach millions of viewers on any device anywhere. And that's obviously one of the huge gaps that people have, this negative perception of WebRTC, that it cannot scale. And then it also needs to be secure. So the security side of it is funny. We'll talk a lot about security because true end-to-end encryption really doesn't exist in streaming these days. And I'll talk more about that. And that's a little bit of a controversial comment, but I'll explain it later and explain to you why true end-to-end encryption is actually something that is going to be required as we go forward into the future, in addition to protecting your content as well. So human nature craves interaction. Interaction leads to engagement, and that's what everyone's trying to do with video. Everything from watch parties to virtual audiences. Roger Goodell, the NFL commissioner, that's American football. I'm originally European, so it's not proper football. But he did comment that digital has its advantages. It has an interactive element that cannot replicate a linear feed. And these platforms are reaching different fans, younger fans, and they want to engage all their fans. And you've seen the NFL try to do this with the virtual draft this year, where they draft amateur players into the professional leagues. They've tried to embrace Microsoft Teams with their relationship with Microsoft. They have a commercial relationship with them. They've tried to embed NFL streams into Twitch and offer the rights to Twitch to be able to rebroadcast that, to embrace some of the interactive features of Twitch, including chat. And they've been able to, they tried to use Microsoft Teams to create an interactive element with kind of a failure back in September when the NFL season kicked off. So this interaction that we're craving is made all the more obvious by what's happened in this last year and talking about, and I won't even mention the word because we're all exhausted by it, but the reality is we all need to make remote interactions feel real. Everyone's trying to get there. Some are succeeding. If you guys have heard, it's all the rage right now, is Clubhouse. Clubhouse is an app that's only available on mobile devices currently by invitation only. I fortunately have got onto that and I've been able to actually interact with Clubhouse. And the idea is it's audio only currently, but it has this interesting concept of making the experiences truly, truly interactive. So when you are a passive listener in Clubhouse, you can be upgraded to an actual host. And this is kind of like Jerry Springer style. If you know Jerry Springer here in America, someone says, hey, that guy is the father of my baby, and the guy wants to defend himself. You give him the mic and he can jump over and defend himself. And then you can make them passive viewers and bring on the next guests. That two-way interactivity is something that really isn't being done in any good way. Zoom, Teams, a lot of these RTC real-time communication tools are trying to do that. But the reality is nobody's doing it really well. Clubhouse has been able to do that. They've built it on top of the Agora WebRTC stack, so they are using WebRTC to do that. But to scale it to the size that Clubhouse is doing it with audio is one thing. Doing that with video and audio is something completely different. Obviously, audio does not have B-frames, which is one of the big reasons why it's able to scale quite a bit more efficiently, in addition to the fact that data is so much lower. The NFL, like I mentioned previously, did that through Twitch. It's done that through Prime. And there's been all these new interactive startups that have popped up in the last year. There's one called Hop In. There is Around, which is actually a tech stack that our parent company at Millicast Cosmos helped to build. There's Startup Run the World. All of these have got crazy amounts of funding because investors realize and recognize the value of trying to build this interactivity. And the reality is much more value will follow. And let's talk about real football for a second. Man United, which I'm not a fan of, by the way, I'm a Liverpool fan in England, but Man United is one of the biggest brands in sports and probably across, it kind of transcends even sports. You know, Old Trafford, their stadium, they have a capacity of 76,000. The average ticket price in 2019 was £173. They can generate £13 million of revenue per game, right? But the reality is in 2020, they were close to zero in revenue with the closures that we had around the world. When we get back to normalcy, which we're starting to do now with all sports, what happens if Man United can truly embrace their brand and own their value, which is happening with all brands around the world, not just sports, and be able to access the biggest fan base in sports, which is 659 million fans around the world, all over the world. If they can really create some kind of engaging virtual seat and own the rights to their own content and only sell that for like £1 per ticket, they can potentially generate revenue of 659 million pounds just in one club, in one league, in one sport, in one vertical market. So the ability to create a kind of virtual sea or an interactive experience, think about it now for all these different markets. There's going to be no market that's going to be left untouched. Everything from live sports to video-enabled e-commerce, which funnily enough is a vertical that has barely been touched. The surface hasn't even been scratched when it comes to selling things online. I've been working on a proof of concept in London with Ralph Lauren, who's trying to create virtual shopper experiences for their customers who still want to be able to shop in store but can't and want to do it remotely as well. Live auctions is an obvious one that real-time streaming is needed for. Cloud gaming, AR, VR, remote production is actually an emerging market that has really just popped up in the last 12 months. And we'll talk more about that. The actual ability to work on films and TV shows remotely and be able to collaborate when it comes to color grading, pre-production to look at sites, during production itself to look at different camera angles. The NFL actually used us for the Super Bowl this year with 120 cameras in stadium. They wanted to monitor those stadiums in real time, and they were using Millicast to monitor the real-time feeds because trying to do 120 through conventional broadcast equipment was just too difficult. So it's interesting that you see technology being used in innovative ways to add that interactivity. And the reality is that interactivity is going to unlock value in many multi-billion-dollar markets. Betting and gambling is one that it needs to be because of fraud issues. It needs to be sub-second. Live events, health and fitness is one that we're seeing a huge amount of development in. Everything from ClassPass launching a live streaming service. Peloton did that. I remember when we were at Wowza, we worked on a proof of concept for them, and they need to engage with live classes now more than ever with COVID. Education, and then watch parties. Watch parties is a great example of somewhere where people want interactivity in a remote scenario with traditional high quality linear streaming coupled with the interactivity layer. So Hulu has launched their watch party service. Disney Party has launched, which is available on different devices. Facebook Watch Party, there's just a range of different ones, and they're continuing to grow. The reality is interactivity is going to become as ubiquitous as email and web browsers. And the value of interactivity in the next 10 years is going to skyrocket. In the next 12, from 2019 to 2030, it's going to grow 12x. In the next 3 years, it's going to grow 12x. And in the next 12 years, it's going to grow 100x. This is the BitMove Video Developer Report that doesn't quite focus in on the idea of interactivity, but it does show that the two biggest issues that are happening in the streaming industry are live streaming at scale and viewer engagement. And how do you couple those two things to create true interactivity? And what most of us care about on this call is, what is the value right now? Like, why am I spending 3 hours here? Well, it's probably because you guys are running your own streaming services, you're building solutions, you have customers, you care about it yourself, you have your own product or your own brand that you're trying to add value to. And that value of interactivity is going to be the fastest growing segment of video traffic and video streaming in the world over the next 2 years. you can see now that within internet traffic, we have internet video. Within internet video, we've got live video, then we've got real-time video, which is traditionally associated with real-time communication and maybe some, use cases. But the interactive streaming element is going to pretty much take up the entire real-time video network. But there's no solutions really in place to be able to do that. So that total addressable market by 2022, and just by the end, pretty much a year and almost 2 years, is going to be $7.5 billion, according to the Cisco VNI report. And I have just a couple more slides here, and then I'm going to start jumping into some hands-on workshops, because the last thing I hate is just someone talking incessantly and selling you on their vision of where streaming is going. So I actually want to show and get our hands dirty and talk about true WebRTC workflows that you can start using and take with you to start building solutions on top of. But in order to attain this interactivity, how can we achieve it? Like I mentioned in the previous slide, to be interactive, to have two-way exchanges, you need real-time, high-quality, web-scale, secure features and abilities to be able to enable that interactivity. So let me give you a clue what it's not. It's not Flash. Flash is not going to come back and save us. As much as we all try to hold on to RTMP, and we, even though Flash has died, the remnants of Flash is still around, and many of us are still, myself included, I really did love Flash. But Flash isn't going to be the savior. The best positioned technology in the market to create this interactivity layer is WebRTC. And funnily enough, that's still controversial in streaming. And I find it fascinating that it is. But I'll explain why it's controversial. I'll explain why it shouldn't be controversial, why it should be the obvious answer to what we're all trying to do with interactivity. So to see it in action, let's jump into one of the first workflows. This is the simplest workflow with WebRTC, which is using a browser to broadcast and encode, and using a browser to playback and decode. So I'm going to jump on, and like I mentioned previously, obviously I work for Millicast. We're sponsoring this workshop, but everything that I'm showing you is going to be possible with Millicast and our platform as a service, which is a WebRTC platform. But you can just as easy build other solutions just with the open source WebRTC up to a point. When it comes to scaling, that's when you probably need a vendor to help you with the scaling aspect of it. But what I'm going to do right now with Millicast is show you something that you could just as easy do by pulling the open source code from WebRTC and starting to do it. And it's already something that we're all doing in some respect every day with Google Meets and other WebRTC-based technologies. So if you go to millicast.com, it's as easy as clicking on this demo button. It pulls up the web browser, and I'm using Google Chrome here. I could just as easily be using Firefox, Safari, Edge, even my mobile phone to be able to do this. And in this demo, you can see how to use it. All I have to do is click on Start. I choose my audio source. Here I have all my local audio sources on my MacBook Pro. I'm going to keep this NDI because I don't want to get an echo with this. And here I get to choose my camera. I've got other virtual cameras. I have OBS running on here. I can even do NDI video across my network. But for now, I'm going to just use my camera here, my FaceTime camera, and I'm going to click on Start. And you guys can go and do this directly inside of Millicast, just to get an idea of what the latency is like and all this is like. So as soon as I do that, you can see that inside this demo, it shows me a playback URL. I'm going to copy that, and I'm going to play that back inside of my browser as well. Now, what I'm going to do is you can see here my, my video that's actually being shared. It's hard to see the latency right now, but what I want to do is actually come back to the broadcaster, and I'm going to share this in the chat window so all of you can pull this up on your local browser, whether it be your mobile device or anywhere else on your Mac that you're on, your Windows device, on your Apple iOS device, wherever you want, you can play this back. Now, you'll notice that with WebRTC, there is no additional plugin you have to grab. There's no additional technology you have to install, like we have to do with Zoom and Log Me In and WebEx and all these technologies. It works natively inside our devices. And I think you guys already know that about WebRTC. But that's a very simple demo. With a Millicast platform, we can scale this to millions of concurrent viewers. But this is just one idea of what we can see just from this demo inside of this. Now, what you'll notice is that we can choose here maximum bitrate, which will let WebRTC intelligently decide how much bitrate I currently have available. Obviously, I'm taxing my network right now by sharing Zoom. I'm doing this as well, and we're probably going to see quality issues because of all that. But what you can also do is force lower bit rates. If you want to force 720p at 1 megabit per second or 2 megabit per second, all that, these are all things you can also force inside of WebRTC. The real thing about this demo that's interesting is that with this, we are limited by what the browser allows us to do. You know, browsers follow standards, and a lot of the technology that we want to do with building in broadcast quality isn't yet available inside the web browser. So Google Chrome limits us to 422 color, not 444 color. It limits us to you know, doing HDR and capturing HDR inside the browser and encoding. We'll have to use a separate encoder to do that, something that's a little bit more high-end, maybe even a hardware encoder. But the playback of the device still works, whether it's in web browser or whether it's with different devices like an Apple TV and other things like that. So that's that example, very simple example. I'm going to go ahead and stop the broadcast now. I'm just going to close this browser out. So you'll see your stream if you're watching that, that will die off. The second demo I want to show, if I go back to my PowerPoint real quick, is I want to show a quick demo on how to do something a little bit more feature-rich. What I want to do now is show you an end-to-end WebRTC workflow that is being used by the remote production industry. And what's being done in remote production is people are using Adobe Premiere, After Effects, they're using Avid, Media Composer, and even Pro Tools from a sound perspective to collaborate on post-producing music albums. And different editors and different producers are in different parts of the world, and they all want to collaborate on different things. So how do we capture a high quality feed for some of these tools, even 3D tools like 3D Studio Max and Maya? How can we capture the output of this and be able to stream it so people can collaborate in real time? And this is a real thing that people are trying to do in the production industry. And I'll speak more about some of those exact use cases. So one workflow for that is to do it all in software. We're actually using NDI, which obviously is a protocol that NewTek developed, and it's become very popular. It's embedded inside of Adobe and a lot of tools that allows you to pull the output from Adobe Premiere and do whatever you want with it. You can share it across your local network. Now, what OBS can do, OBS is the open source broadcaster. You can capture NDI and use that as a source, encode it, and then stream it out over RTMP, right? Well, what we've done at Millicast and at Cosmos, which is our parent company, we've taken OBS, which is an open source project, and we have forked it to include the WebRTC stack directly inside of it. And I'll talk more about that later on, but what it allows you to do is, instead of having to send RTMP into Millicast, which doesn't include, you know, other codecs, it's not codec agnostic, there's issues like that. With OBS WebRTC, it will use WebRTC natively, which means we never have to touch and re-encode the video and the audio coming off of that. We'll send over H.264 or VP9. It's codec agnostic. We'll send OGG, which is the audio codec used inside of WebRTC by default. And then Millicast doesn't have to re-encode that or transcode that at the server level to be able to deliver it. All we do is reroute it and we scale it. And that's a real amazing thing about OBS WebRTC. And there's not just Millicast customers that are using this, there's other WebRTC solutions that are using this version of OBS as well. So I'm going to show you a workflow with that exact tool. So if you go to GitHub and you go to Cosmo software, you can see it here. And I'll go ahead and put this inside the chat window. And I'll go ahead and share that. You can go here and you can see the second project on here is OBS Studio WebRTC. You can click on that. And then under the releases over here on the right, I'll click on that. And here's where you can download the newest version. So you can see there's a new beta here. And if you click on assets, you can download a Mac DMG. You can load a Debian file for Linux and an MSI file, an install file for Microsoft Windows. So I'm actually running OBS Studio right now inside of my machine here. So I'm going to go ahead and switch to that. And I'm going to bring it over here to my shared screen. So if you guys don't know OBS, OBS is probably the most used encoder in the world because it's free. And that's the traditional version of OBS. This has the exact same tech stack with all the features of OBS, with the additional functionality of having WebRTC built straight into it that we've been able to add to that. So when OBS comes out with new versions, we're able to then repackage that with the new features of OBS, with a fork that we have, but then send this out. We are trying to get OBS and other encoder vendors to add functionality inside the WebRTC functionality by default inside of their encoders, including OBS. But as of right now, they've not done that. So this is a reason we have this forked version. So inside of this, I can actually add new sources. So you can see I have a display capture. I'm getting the repeating window there. Let me do a media source. So you can see here I have a 360 video. This is a pre-recorded 360 video that I have available. I can also do my camera. So inside of here, if I choose video capture device, I can add that. And I can also add my FaceTime camera. And I can very quickly do picture-in-picture if I want to, do a screen share, right? Get rid of the media source, and there's my picture-in-picture. So people use this as a very quick and cheap and easy way to pull in different local sources, produce them, and then be able to stream them directly into Millicast or their WebRTC platforms. So OBS, fantastic tool, highly recommend it. If you've never used it, you should definitely get onto it. So what I'm gonna do now is just connect OBS to Millicast. And the way we do that is you come over here to settings. Under here, you can see in the general, I've got different features. I'm going to choose stream. And you can see that Millicast is in here. Obviously, we've forked this solution. So we have Millicast in here as the default platform. But you can take the fork, add other WebRTC endpoints if you want, or just use ours. And you see here, I have a stream name and a publishing token. And I can choose which codec I want to use. As of right now, we only have H.264 VP8 and VP9 available inside of OBS, but AV1's coming. Whether it gets built into OBS or not is a different thing, but we'll talk more about AV1 later in the presentation. So what I'm going to do now is jump back into Millicast. And all you have to do is, if you do want to sign up for a free trial, we have a forever free trial at Millicast that gives you 50 gigabits and never expires. So if you want to come in and test and use, you can try for free, fill in the form, and there's no time limit on that. You can just come in there and do that at any point. But what I'm going to do, I'm going to log into my account. And it's going to auto detect me. And inside of here, you see I've got my different stream tokens that I've created. So I'm going to create a new one here for OBS. So I click on the plus sign. I'm going to add OBS Studio WebRTC. I can choose to record. I can secure the viewer, so you have to have a password to be able to use it. And here I can actually accept any name that comes in, or I can create multiple stream names depending on what I want to do. And everything you're seeing inside this dashboard is built on top of our API, which anyone else can use to go and develop their solutions and white label solutions. So what Millicast is a platform as a service. We don't get into the SaaS, the vertical markets, whether it be live auctions or remote production, or we just have the underlying WebRTC stack that we've been able to crack the code on how to scale that, add quality, and so on. And we give you all the tools to go and build your solution for real-time communication, for whatever your vertical market happens to be. So everything you're seeing here, you can build your exact same interface that you're seeing right here. So I'm going to go ahead and just say use any name, hit OK. And when I come into that token, you'll notice here I have those settings, and I can come into the API settings, and here's the information that I have available, plus publishing call examples of how I can interact with the REST API that's available inside of Millicast. But if you're not a coder, if the minute I said API, your eyes glazed over, don't fret. We can do this all with what you see, what you get, copy paste. All right. So all I'm going to do is actually just choose a publishing token, copy that, come back into OBS. I'm going to remove the stream name, and I'm just going to say OBS just to give it something. And I'm going to paste the publishing token. Now, what I can also do here is I can come in and I can start now choosing a lot more control over the encoding settings, because OBS is a software encoder. I can choose a lot more than I can even do inside the web browser. The web browser limits you. There is a lot you can do, and we have a broadcaster SDK that allows you to build a encoder in browser, like the one we just saw in the first demo, that you can take that code base and then go build your own and use all those features. There's a certain amount of control, but you're never going to have the same control, at least not now, than you can inside of a software or a hardware encoder, where you can come in here and choose all the different bit rates, set keyframes, set all these different things inside of here. So I'm going to go ahead and select 2.5 megabit per second, audio bitrate at 128. That all sounds good. Hit OK. Final thing, I just want to do my video. And I'm going to go ahead and keep it at 1080p at 2.5 meg. It's a little bit low, but I don't want to tax my local network too much. So I'm going to hit OK. And now I am going to start streaming. And you can see just like that, it started streaming. Down here, it says I'm live. If you see this at the bottom of my screen, it's telling me how much CPU and my frames per second. That's my connection on my, to Millicast. So if I switch back over now, all I need to do is come back here into my API, and there is a hosted player path. So we can either host that and send people directly to it, or you can embed this inside your own web page, and you can customize that embed code, customize the size of the player, and so on. But let's actually see the quality of the stream that's coming off of this. So what I'm going to do is actually paste this inside the chat window, so you guys once again can see that in real time. So the other thing I'm going to do now is just come into Adobe Premiere. I'm doing a playback on here of a video project that I have in here. So I could be editing this video as someone who's remote, right? But if I come back into the player, you see there is the playback. So there's a workflow using OBS with an NDI source, and the ADI could be coming from everywhere. We also work with BirdDog, and I'll be talking about BirdDog more later on. With BirdDog, they have an NDI cloud, and they have devices that allow you to do a remote IP camera, pan tilt zoom, all over NDI. And they've created an interaction with us that allows us to pull NDI from the BirdDog cloud through WebRTC into Millicast for scaling purposes. Let me actually just go along with the presentation, and then I can show you guys an actual 360 demo in real time using that natively inside the browser. At Wiles, I did a lot of VR 360 workflows that were all RTMP focused with different vendors that did player technologies, right, that you had to use to be able to then play back within the browser. The nice thing about this VR and 360 workflow is the fact that we have an implementation that works with WebRTC that works natively inside the browser without a third-party player or a custom plugin. Let me go ahead and just return to the slides. And I think for us to truly understand where we have to go with WebRTC and interactive use cases, I think we've got to talk about where we've been. So let me talk a little bit about the past. And when I say a little bit, I mean a little bit. I'm going to try to get through this in less than a couple of minutes, because all this is stuff that I think all of us know as broadcasters and streamers over the last 15 to 20 years. So the frustrating thing about Flash is that with Flash, we had it all, right? And this is 15 years ago when 2005, I think, was the first Flash media server that came out. Then it became Adobe Media Server. And the reality is we had end-to-end security. You could actually encode using the Flash media encoder. It would encrypt it then, and it wouldn't touch the stream again until it actually came back to the player, especially if you're doing like a simulcast and you weren't transcoding. It allowed you to have true end-to-end encryption. To have true end-to-end encryption, you can't do transcoding at the server level, because it means you have to unpackage the protocol, take out the video and audio, transcode, and then repackage into either the same protocol or another protocol. The minute you can access the content inside the protocol, it means encryption, end-to-end encryption is gone. How a lot of people do that in streaming now, actually, I'll talk about that on the next slide. So end-to-end security, we had that with Flash. We had a low latency application. It was like 1 to 3 to 5 seconds. It was actually pretty decent for a lot of real-time use cases 15 years ago. We had encoder control with the Flash media encoder. We had playback control with Flash, and we had interactivity inside of the Flash player with ActionScript. If you remember FLV files and SWF files, right? And having to build, I miss ActionScript so much, guys. Like, I was a bit of an animator early on. I remember when South Park and The Simpsons were using Flash for it, and then it kind of evolved into this beast, right? With video playback and all that stuff. And because I was never that good of a coder, I loved the what you see, what you get, part of ActionScript. Anyway, I'll digress. But the reality is, it was too good to be true. And what happened was there was device fragmentation. Really, it was the iPhone that killed Flash, at least started the beginning of the end. Steve Jobs and Apple decided, hey, you know what? We're not going to support this on our devices. And with the ubiquity and the way that mobile devices became predominant, all mobile devices stopped supporting Flash, and iOS gave us an affordable replacement for most streaming use cases with Apple HLS, right? So for 90% of the use cases that were out there, latency wasn't really top of mind. They cared more about cost and scalability. And the truth is, Flash had legitimate security concerns. It was a third-party plugin. It needed you to download, keep it up to date. There were all kinds of security issues that were notorious. And ultimately, web browsers and web-enabled devices followed Apple's lead and stopped supporting Flash. CDNs as well, like Akamai and Level 3 and Limelight and others, they soon quickly realized the cost savings of moving to stateless media files. And what this means is stateful means that you have a connection with the server that's serving you the file. RTMP, if you did RTMP end-to-end, that's a stateful connection with the server. It's more expensive for CDNs to scale because they need to have origin servers, right? Wowza as well, you need to have a ton of Wowza servers to be able to scale that. The minute you can generate an HTTP file and just save it somewhere, now scaling that is a stateless file that it's so cheap to scale. It's how most of the web now is served through HTTP files. And that's why you create these little chunks, right, with M3U8s, because you can just put them in simple storage, put them on the edge. And that's how all of Akamai and everyone does most streaming nowadays with HLS and Dash. So that started a race to zero for bandwidth cost, which all of us as streamers and broadcasters loved, right? Because we loved the fact that we didn't have to pay $1 per gigabyte or $10 per gigabyte. We could pay 5 cents per gigabyte or 2 cents per gigabyte, especially as we did more volume and scale. And media bandwidth really became a commodity. So this is kind of the device fragmentation that ended up happening at the media server level. Is we had Flash Media Server, which is definitely the predominant, and then it became Adobe Media Server. We had Windows Media Server, right, with Silverlight and all those WM, or MSS and all that stuff. We had QuickTime as well, and this is probably going back to early 2000s. We had real-time, and then we had multicast over IPTV networks and so on, right? So there was this huge device fragmentation across all these devices. Wowza was one of the first that was just in the right place at the right time. They started supporting HLS. They also did Flash, RTMP. They also did RTSP. They became that kind of ubiquitous, we can do it all media server, right? And then they started being able to do transcoding with ABR, and HLS and Dash became predominant. And Wowza is still an amazing product, and they're an industry standard. And we've got a ton now, right? With AWS Elemental, with Mux, with all these guys. But the reality is with this workflow, there is no end-to-end encryption. The minute, like I mentioned previously, you have to unpackage the RTMP and transcode, you're having to take away the protocol and the security. You're having to look at the file. The reason I'm going to spend a lot of time talking about security and encryption is because the minute you have to touch that file, you have liability as a service provider. If something happens on your network, whether it's adult entertainment or whether there's very government use cases or military use cases or sensitive content, WhatsApp has launched this, FaceTime is launching end-to-end encryption. People want to make sure that they don't do it. And as a tech provider, you remove your liability when you never actually get to touch the video and audio and have to re-encode it, because you never get to see it. It truly remains end-to-end. And this is a very important concept where when we're building the new generation of streaming applications, it's critical that we build them with true end-to-end encryption, because it's what everyone's requiring of us with privacy concerns and security. And it will be a standard with all streaming use cases within the next few years. And obviously, Flash left a hole in the industry. We stopped caring about latency. With HLS and Dash, people were okay with 30 seconds or a minute of latency. But then we started just getting used to that. And it works great for VOD, right? Netflix has made that a great model. Latency is not an issue, obviously, with VOD. But the real-time streaming use case just got forgotten. And so you've got everything from two-way web conferencing, telepresence, real-time device control, user-generated content, game streaming, eSports, adult entertainment, gambling, gaming that just got left by the wayside. Many of them are still trying to, exist on live support with RTMP. And there's still some providers, Limelight and, even Wowza users still do that. And what's happened as well, as we've tried to fill in the gap and the hole, people have tried to push their own technologies and their own proprietary workflows. You have HLS that's trying to do LLHLS, trying to do, CMAF and chunking and, like micro chunking and all these different things with HTTP media because it's so ubiquitous now. But the reality is it just can't get anywhere near sub-second, which is needed for so many use cases. And RTMP tuned, you can't deliver RTMP tuned. There's some solutions out there that do that, and you need a special SDK to do that. WOWs are trying to do this with their own WOWs protocol, with an ultra low latency product. It's been end of lifed. They realize that nobody wants a proprietary end-to-end workflow with a custom SDK and a custom protocol. SRT has done this from a contribution perspective, but it's not a delivery protocol. So, once again, none of these that are mentioned here are internet standards. WebRTC is. It's an internet standard as of January 2021. As of a month ago, IETF and W3C have ratified that as a standard, and it's built for this use case. So how do we go back to the future? It's 2021. It's almost 20 years since we were using Real Player and Flash to do what we're still looking to do 20 years later. It's so frustrating. We want the same workflow. We want end-to-end security, control of the broadcaster, control of the playback, near real-time latency, and interactivity. And we need to learn from Flash's mistakes. We have to get it right this time. We need it to be resilient. We need to do something about packet loss over TCP. We need it to be codec agnostic so that the protocol doesn't dictate what codec you want to use. We need there to be NAT traversal. We need there to go across enterprise firewalls and government firewalls. And how do we create that NAT traversal? Well, if you use an internet and web standard, well, obviously you have that NAT traversal, right? So we need to have end-to-end encryption. We don't need to have third-party plugins or a custom player or a special SDK or proprietary workflows like SRT, FTL, NDI, WOWs, and HESP. All of these are vendor-specific workflows that they're trying to get you to buy their product. We need a standard that works for everyone and already works on every internet-connected device. So I see the questions coming in. So I'm going to just jump in because as I talk about this, this is when all the traditional streamers start getting riled up, myself included. So Lucas is asking, how scalable is the stream you've just shared? What is being done to make it scalable? Lucas, I'm going to come back to that later in my slides because I go into quite a bit of detail on that and it's quite technical. So just to give you the quick answer is with Millicast, we can scale to over 1 million concurrent viewers per stream. And we have had real-time use or real use cases that have reached, I think, 500,000. But we've done very extensive testing with a tool called Kite. That's an open source project that we maintain. And we've been able to battle test our product to support hundreds and thousands of concurrent streams and millions of concurrent viewers on each of those streams. Gustavo's asking, how is scalability for WebRTC on Millicast? Does Millicast provide a CDN? Exactly, Gustavo. So Millicast is actually a WebRTC CDN. It's a good way to look at it. It's a platform as a service that also gives you the scalability to serve that to the end users. And the reality is, the reason that WebRTC has been so slow to be adopted by so many traditional streamers is trying to do it yourself is a bit of a nightmare. If all you want to do is create like a watch party, and a lot of people are trying to do this, it's quite easy because you can limit that to maybe 5 or 6 concurrent viewers and you're doing true peer-to-peer between them. That's fine because you're not using a server to scale, you're sharing those files between peers. That ultimately is the origins of WebRTC, and I'll go into that here in a bit. The minute you try to scale that to millions of passive or active viewers, that's when the complexity of WebRTC starts showing cracks, right? And there's very few true scalable WebRTC solutions that are out there. Lucas is asking, how is RTP's latency greater than WebRTC's? The underlying WebRTC stream is an RTP stream. I have some slides later on where I go into that, Lucas. Let me leave that because it's a bit more technical. Ultimately, WebRTC is real time. You can't wait for packets that are lost, right? So the minute there is packet loss, you just let it go because it's more important to serve it with a little bit of packet loss than it is to wait for a packet to catch up and serve it, right? So ultimately, how you manage and optimize packet loss is really the bigger question, not whether there is packet loss, right? With WebRTC on our network, we have seen up to 200 milliseconds of end-to-end latency at scale. On average, it's 500 milliseconds at scale. So obviously that's pretty low latent when it comes to comparing that to any other protocols and solutions that are out there. Ralph has a question: if encoding is happening within the browser, what hardware resources are needed or recommended at the source, if I understood correctly? That's a great question, Ralph. I'll go into a lot of detail on that. We have some really interesting stuff. When we talk about AV1, our lead media engineer, Sergio Murillo, has got AV1 real-time encoding working in Chrome, which is a bit mind-boggling when you hear people talking about AV1 real-time being a complete resource hog. We have that working on a standard MacBook Pro. Yes, it has a lower frame rate. Yes, it has a lower resolution, but it's working. And within, with the launch of Chrome Canary M90, which is coming out here in a few weeks, that's going to be available. And I'll go into detail in one of those slides. So I'll talk a little bit more about resources. You'll be surprised. You can do encoding. Of course, a lot of that can be done in software, and a lot of it can be done in hardware. And I'll be going into more detail here in a bit as well. Do iOS, Android apps support WebRTC? Yes, they do. They support right out of the box. Or is it exclusive for modern web browsers and web views? So I have a slide here coming up that will answer that question in more detail. And Dennis is asking, do you have any functionality to configure MCU based on Millicast? Great question, Dennis. I'm going to come back and answer that in a lot of detail, probably too much detail. So I'll come back and go a little bit deeper. So when we want to learn from Flash's mistakes, let's get it right, right? And that's what leads us into the present. We've talked about the past. We've talked about where we've been. Let's talk about where we are. And that will set us up to talk about where we're going. So let's talk about the present. WebRTC has become an internet and web standard as of January 2021. And when I joined Millicast last year and I was talking to Dr. Alex, I'm like, really? Isn't that already standard? Like, isn't it already built into the browsers? And what's crazy about that is that it's 10 plus years of work by hundreds, if not thousands, of people at IETF, W3C, the Alliance of Open Media, all these people who have contributed to making this a standard. Now, when it comes to standards, this is a huge deal. It means every device that wants to be certified by the IETF and the W3C, which are the two committees responsible for telling us how to interact with the internet and what's a standard supported technology in that, needs to follow these standards. And what it also did is it solidified WebRTC 1.0 and set a benchmark for this is where you need to develop for, which hadn't been done until that point. Everything else up to that point let people pretty much have their own custom implementations of WebRTC. What it means is that every new device that's being built and developed, and this has already been happening for a while, needs to have WebRTC built onto it. We'll also talk about AV1. AV1 with the Alliance for Open Media is yet another standard that will be built onto silicon and onto software and hardware implementations and become a standard that is available to every device that's being built out there. Everything from our mobile phones to our laptops to our smart TVs, both for encoding and decoding. Everything from a drone to a GoPro to these standards are going to be built on those internet-enabled devices. And that is huge. If you go to, if I switch over to the browser real quick, you'll see here, and I've got these links in the slides, W3C put out a press release back in January where it talks about the IETF and W3C and what's involved in doing this, the use cases, the next generation of use cases that this enables, like everything from Internet of Things to machine learning to virtual reality gaming to, just this untapped market that is going to be able to embrace WebRTC as a standard protocol on all these devices. It's really mind-boggling. The WebRTC 1.0 and the real-time communication in browsers, as of 26th of January, this is what's set in stone. All the technology that goes into every browser, Firefox, Google Chrome, Microsoft Edge, Opera, all these Safari, all these standard browsers have to follow this standard. So it means that just like we've got used to using RTMP and a certain benchmark of RTMP for our hardware or software encoders, we can have that same stability now with WebRTC. It's the perfect time for us to be doing this workshop, for these technologies to be built, for interactivity to come to the forefront of what's needed in live streaming. It's just this perfect storm that is going to make standardization of WebRTC. I really, really do hope that by this time next year, we do Stream Media University, every major encoder vendor, software and hardware encoder vendor, will have this standard built onto the device. Maybe it's wishful thinking, but I think they're going to not be able to ignore that possibility. Let me go back to the slides. So this is huge. A lot of what Cosmos has been doing, which is the parent company of Millicast, they've been working with Google and Apple to actually help them with their WebRTC implementation, to test their WebRTC implementation. They have this really deep knowledge base when it comes to it. And I'll try not to talk too salesy about us, but it is important to note that it's the reason that we've been able to crack the code on a lot of what WebRTC needs to be, because of the fact that we've got this 10 years. And I say we, I'm piggybacking on the success of others there. Dr. Alex and Ludovic, our mathematician, and a lot of his team, they're the ones who have done the hard work on putting all this work into these standards. And it's a big deal. We need standards to be able to have repeatable, predictable, reliable solutions. So what is WebRTC? You know, there's a half of you on this workshop that are like, hey, I don't even know how to spell it, right? Or I can barely spell it. Well, what WebRTC is, it was a purchase by Google, you know, years ago. I think it was like early 2013 or something like that. And they purchased it and they open sourced it. And it was a free open source project that provides web browsers, mobile applications with real-time communication via simple APIs. All an API is a way for you to easily communicate with deeper technology. So an API is a way for us to develop a solution inside of a web page that the underlying technology is stuff that we don't know how to do. I don't know how to do coding in C and C++ and all these things. All that is bundled together, and the way we can access that functionality is through an API. So that's all WebRTC is. It's a way for us to use these APIs to use this deep level of functionality that's been built by people hell of a lot smarter than me and a hell of a lot smarter than most of us. It allows audio and video communication to work natively in web pages and web-enabled devices. Like, how mind-blowing is that? It's native. We don't need a Flash plugin. We don't need a custom HLS player. Like I love those guys, JW Player, Next Player, and BitMovin Player, and Theo. I've worked with them. I love those teams. But the reality is, you don't need those guys to play back WebRTC. It just works. It works on every Android device, on every iPhone, on every web browser. It's mind-boggling. Every smart TV, right? Like it's crazy that is just going to be something that's ubiquitous, and it's on every single device. That's really a game changer, right? When it comes to trying to reach every single device you're trying to reach. So this will enable not just the native playback, but the native broadcast from every mobile device, every smart TV, computer, Internet of Things. This is a project I worked on at Siemens when I was at Wowza, where they had this little robot and it had a camera on it, and we created a real-time streaming solution. You could use it as a security camera. Well, imagine now with WebRTC, that's real-time. You could actually be at work and you're controlling the robot and seeing the video in real time. That's possible that's actually so simple with WebRTC, just with a default implementation. You can do that yourself. You can build that into a drone. Imagine like, I remember working with Shell Oil on a streaming use case where they were trying to stream from an oil rig, and they used to have to send a helicopter out, capture the video, stream it through a satellite. Now you can do that with a drone, a DJI drone for $500. You could capture the video, send it over the Wi-Fi on the oil rig, send it over WebRTC to someone who's remotely operating it. Think about the cost savings. Think about people who are trying to do this for industrial use cases, trying to look at dams. They want to analyze where there's cracks in dams, and they have to rappel down in the past and do that all manually. Like space station, you know, going out and doing moonwalks to go look, or spacewalks to go and look at the space station and different shuttles and SpaceX. You can do this all with WebRTC now, right out of the box. It's really crazy, right? When it comes to game consoles, the way we interact in gaming, the way we interact with VR and AR. I'm so excited. And as we get back to the question that we had earlier about which devices are limited, well, really, what we can do on a smartphone these days is more than we can do on a computer 10 years ago, right? It's crazy that smart cameras, I got, these glass cameras, all those things that haven't really become popular will become popular, and there'll be all these use cases where a tiny little bit of silicon can do everything that a computer could do 10 years ago, right? And this WebRTC sets the groundwork for all of that to happen. So I have a quick question here from Jeremy. Is WebRTC useful for VOD playback or only real-time live? It's a great question. So yes, with WebRTC, you can record WebM and you can play that back natively with inside the browser. Really, it's not really WebRTC as a protocol. You're really just playing back a WebM file natively without needing a custom player, right? And you can control that all with HTML5 code and CSS. What you might be asking here is how to scale a VOD file. That is not something that's currently being done that I'm aware of. It's an interesting question. The economies of scale with VOD, you're better off going traditional route and having a VOD scaling service. We do have a recording service in Millicast, and we are going to be building later this year a VOD scaling service that allows you to serve that through HLS or Dash or other ways that you could scale it. That's not currently being done with WebRTC because the economies of scale of doing that with origin servers doesn't quite work out. It's also a reason, like at Wowza, we didn't do a lot of VOD stuff because you were better off creating the chunks and then putting those chunks out on Amazon S3 or somewhere for people to download and scale it that way through a CDN. So not really a use case, but you can record VOD through WebRTC platforms, whether it be Millicast or Janus or other places. There is a recorder available inside the broadcasters. You can also record a local version of a file. If your bandwidth goes down, you have this local version that you can do stuff with. So I have a deeper question here from Eric, but I'm going to talk about this later. We're talking about on-premises Millicast node to reduce bitrate. We did in the past, in the early days, we built on-premises solutions for other vendors, but we don't do that currently. If you do want to do that, you're better off going with like a Janus WebRTC or other WebRTC platform, the Meduse WebRTC platform, which is was created by our own Sergio Murillo. Like there are other open source solutions that you could go and build your on-premises WebRTC stuff, but we don't offer that at Millicast. Ours is truly public internet pass focused. And Christian's asking here, maybe with StreamRoot or Pure 5 to distribute a VOD session. That's an interesting thing, and I knew it would come up during the session. The most that WebRTC has been used in the traditional streaming industry is actually not even WebRTC for media transport. It's WebRTC as a data channel. And how StreamRoot, Pure 5, all those guys have been doing peer-to-peer data sharing is to actually efficiently scale and grab HLS and HTTP files from each other when playing back very large streams. So imagine you have like the NFL, right? And they have the Super Bowl, right? That just happened a couple of weeks ago. If you're streaming that to the city of Chicago, you have a million people trying to view that over an ISP. That ISP may go down because everyone's trying to access the content from an edge that doesn't have, or a CDN, a CDN edge. What StreamRoot and Pure 5 did is they opened up the WebRTC data channel inside the browser and allowed people to access it so you could grab chunks from people inside of your, the last mile, right? So people in your city or in your neighborhood, and that allowed you to be more efficient with the files that needed to be grabbed from the edge. So it's it's a bit of a hack, to be honest. It's obviously worked well for the HTTP streaming use case and trying to scale that and add resiliency. I know a lot about it because I worked with the Wowza team on all those partnerships, but it's not something that is true to this presentation and using WebRTC as a media transport. So look, all that positive, everything that we're talking about WebRTC, we're gonna like save the world, it's gonna bring world peace. Why aren't we already embracing this in the streaming industry? Well, the reality is there's still this negative perception. WebRTC is almost like a bastard child for video streaming. And why? Google gave us this free open source tech stack that right out of the box puts you on par with Ericsson, with Cisco, with multi-million-dollar Fortune 500 companies and their real-time streaming solutions. And right out of the box, you can grab that, go build it, and build your own vertical market SaaS product. So why hasn't the streaming industry embraced this, right? Well, the reality is when it launched, when WebRTC launched, it was very narrowly focused on the voice over IP and the real-time communication peer-to-peer use case. Kind of like Google Meets or Google Hangouts, right? Or technology like that, where you could do that for free with Google Meets or Google Hangouts. And the minute you got to about 6, 8, 10 concurrent people, you were sharing data in between you and it would have trouble, right? And that's why you had limits with Google Meets and any WebRTC implementation, and you still do. Those use cases, when you do that peer-to-peer, it means, imagine Eric and I are doing a quick Google Hangouts. We're going directly to each other. There's no server in the middle. There's no MCU or SFU, these different kind of servers that will intelligently scale or route, or it literally just goes, you know, Eric, you available? Yes, I'm available. Boom, peer-to-peer. And we share video and audio between us. The economies of scale, as you do, you know, 6, 10, 20, 100, multiple people inside of a room, this happens even with Zoom and with native applications, is sharing all that peer-to-peer, there are limits, right? And that peer-to-peer use case, the streaming industry looked at that and be like, well, that's not really us. That's kind of a peer-to-peer thing. Let's just leave that for the real-time communication guys. Let's leave that for Google Hangouts, Google Meets, Zoom, Log Me In, you know, all those guys. Let's just leave it there, you know, Blue Jeans, all those guys. It also had this association with having poor web quality. Because you were using the browser has been very limited, right? As it's been this evolution of the codecs, the evolution of WebRTC, slowly these additional qualities, settings that we've had for 10, 15, 20 years with RTMP and RTSP and even the evolution of SRT and all these different, it's an unfair advantage. You know, you've had so long to develop the different ways to support quality. And even with those established contribution protocols, you still have issues. There are still things that don't work well, right? So trying to, there's been a real evolution as devices have become much, much, much more powerful in software and in hardware, that it's no longer web quality. And then there's also this negative connotation that WebRTC requires coding. You need to be a coder to be able to use it. And this goes back to what I talked about at the beginning of the presentation, where there's this coming together of web and broadcast. And it's been coming together, and we can't ignore it anymore. They are one and the same. You know, when you try to send a broadcast, you need to do it to every web-enabled device. What better protocol and what better technology use than one that was built for that purpose? RTMP was never built for that. RTSP was never built for that. SRT was never built for that. WebRTC is built for that. And now that we've cracked the code on all these things that are negatively perceived in the industry, it's time to, you know, open this up and start using it for real streaming use and broadcasting use cases. And I really hate throwing anyone under the bus. The streaming industry is a small industry. I've been in it forever. But I do need to, and this you know, conundrum is one we used at Wowza. It's one we used that Theo has used. It's one that Bitmovin has used. Everyone's used this. Everyone's used this to justify why you can't have scale, latency, and quality. And this slide is years old. So in Theo's defense, Theo Player's defense, it's very old, but I'm going to use it to illustrate the point that there was this rhetoric, right, in streaming, that if you want to stream to 1 million viewers, you can't do that at low latency and still have high quality. You can do it at low quality, and then yes, you can reduce the latency, and then you can do it at scale, and vice versa, right? And they all pulled against each other, and this created this complexity that nobody has been able to crack when it comes to scaling that, because HLS was there to scale to millions, and it's all efficient and does it well, but then it doesn't have the latency piece. Okay, so let me use something else. WOWs. Okay, great, we can do that, but then you've got to have a bunch of origin servers. I don't know, it just wasn't built for that. So what I'm here to tell you is that you can have your cake and you can eat it too. WebRTC there are vendors in the industry, ourselves included, that have cracked the code on how to build the building blocks that you need to enable interactivity above it. And those building blocks, like I talked about throughout the presentation, it's real time, 200 to 500 milliseconds, sub-second. It's high quality, not just web quality, but broadcast quality, 10-bit, 12-bit, HDR, 444 true color, surround sound, Dolby Vision, 7.1, 5.1 surround sound, web scale, like truly web scale. You can get to every device. So there has to be, like no limits. You have to be able to go to 1 million of concurrent viewers per stream, and thousands of concurrent streams simultaneously, right? And it needs to be secure. We need to have transport encryption. We need to have end-to-end encryption, and we need to do things like forensic watermarking. And this is what brings me to another negative perception that the streaming industry has of WebRTC is, well, what about DRM? There's no DRM content, protection. What if I want to monetize my content? What about server-side ad insertion? What about, and you rattle off all the different features of why WebRTC is not up to the standards. Well, you know what? It just became a standard last month, and it's only recently started to gain the traction that it needs to do all that. So you're trying to compare the feature parity to RTMP that's been around for almost 20 years or more than 20 years, RTSP, HLS that's been around since the iPhone was launched, millions and billions of investment in all those traditional technologies. And with WebRTC, you're now saying, well, I want all those same features. That's going to come, and that's what leads us into the future, right? And that's what we're going to talk about next, is what we already have is here. What we need to build on to get us to where we need to get to is what we're going to talk about in this next section of the presentation. And the reality is the future is now. So let me go through a few of the questions as I go through this. And I hope I'm not putting you guys to sleep. I'm hopefully passionate enough about streaming and everything. Like, I love this industry so much, and hopefully it's coming across as I communicate this all to you. And I am talking a lot of slides and a lot of theory and a lot of vision. I'm going to be getting into the hands-on workflows here very shortly. So Marcus has a question. You mentioned 500 milliseconds of latency with WebRTC. At what resolution are those values achieved? Are we talking about 1080p? Absolutely. So WebRTC itself does not have limits on resolution. You can do 4K, and you can send it across. WebRTC has the intelligence to be able to adapt how much bandwidth you have available and be able to then intelligently encode a variable encode at the source, which is very different than how we do it traditionally in streaming, where you are running a hardware encoder or a software encoder, like Wirecast or a Teradek cube or harmonic or an elemental encoder, and you've got this pipe and you say, hey, I want 10 megabit per second, 1080p, and you send it. And it's constant bit rate, right? And yes, there can be fluctuations and there can be things that happen, and there's resiliency built within it to wait for packet loss and adapt to that. That's a lot of what SRT is about. WebRTC, the priority is real time. The priority is latency, always. And quality can sometimes suffer because of that. But there's a lot happening that I'm going to talk about in the future that is going to really blow the industry's mind as to what will be available within WebRTC, even within a couple of weeks, and what is kind of already available now when it comes to quality and controlling that. And just to give you a hint, it's scalable video coding, SVC. And that's a really interesting concept that really puts the traditional streaming industry a little bit on its head and revolutionizes this traditional theory of ABR, adaptive bitrate, and gives it a whole new edge. I'm going to talk about that here in a bit. Jonathan asks, has any consideration been given to the programmatic advertising space server-side or client-side advertising insertion via IAB standards? So there's some SSAI server-side ad insertion stuff that we've worked on and theorized on and trying to make into a standard. I can talk about that later. I wasn't going to go that deep into it, but hit me up. Any individual questions, shoot me an email at ryan@millicast.com. I have a whole nother presentation that's super deep dive that I can share as well, that goes into things like that. But not a lot. There's not a lot that's being currently done with server-side stuff. The reason, because WebRTC is trying to keep its end-to-end encryption piece, or at least we are trying to keep that end-to-end encryption. We think that's the biggest thing that's happening in streaming is end-to-end encryption needs to be standard on pretty much everything going forward into the future. And we want to be able to embrace that. So the minute you try to add anything at the server level, you break that end-to-end encryption, right? Whether it's transcoding or whether it's adding features, you want to do it at the source and you want to unpackage it at the playback, at the decode. So there's some interesting models of how you can do server-side stuff that adds the kind of data layer, and then the player intelligence can decide how it's done. And to be honest, I'm not an expert on that, but I have slides to that point, and we could get back to you on the expertise there. Robert Reinhardt is here. I think you guys all know Robert. And I still have that bottle of whiskey to send you, Robert, that is still sitting here that I cannot mail to Canada. What does this year look like for hardware-based encoding for WebRTC publishing? How is traction with the WIP initiative with other vendors? Wonderful question. I have a whole section dedicated to that, and we're going to get to that here briefly in the future section. What other options than OBS are available to push WebRTC? A question here from Lucas. Another great question. Another thing I'll address along with Robert's question here in a couple of slides. And Christian's asking again, so again with data channels, can it be used to insert data live, like ad insertion? Well, yep, that's exactly what we were just talking about. And I'm going to show you guys a very cool use case of one of our customers that I was just on a demo this morning that is doing some very cool stuff when it comes to stuff like that and adding interactivity. All right, perfect. So that's a great setup. So the future is now. Oh. So COVID, I said I wouldn't mention the word, but I am. It accelerated a media gold rush in the last year or so to an internet-enabled workflows. This particular slide is an Emmy Award that was given to one of Cosmo, our parent company's customers, Evercast. Evercast built a remote production collaboration solution on top of WebRTC, and Cosmo has the tech stack that they were able to use to deploy their solution in the remote production space. And both Evercast and another technology called SohoNet that also uses WebRTC were able to launch their products in the market. And SohoNet actually has traditional hardware encoders, and they do a lot in that space with file sharing and all that kind of stuff. But they also needed to embrace WebRTC to do kind of what I showed at the beginning, be able to share your real-time screen of Adobe Premiere or Avid or your different editing tools, as well as look at live makeup on set. The makeup artist was remote, but wanted to see, like there was all kind of crazy use cases when it came to remote production. And the Emmy Engineering Awards recognize these technologies in WebRTC as something that was able to keep the lights on in Hollywood, with a lot of TV and film production that continued to roll, even with trying to limit the amount of people on site at the facilities, right, at the studios. And with this kind of opened up with this opportunity. It was like an opportunity that almost wasn't there. Like nobody, you had vendors like Frame.io that were trying to do, and one of our ex-Wowza customers, Grabio in London, or I think their current Grabio is still a customer. They're enabling workflows that allow you to do kind of almost like Adobe Premiere editing in the cloud with kind of, but that's not true WebRTC. It's more like collaborative technologies with caching files. Vmond is also someone who's trying to do this and trying to build kind of editing workflows into the web browser. That's not actually WebRTC. There's a lot more complexity to a lot of what they're doing. But what the remote production space has done is they've recognized that they need to share real-time video. Real-time video for multi-camera shoots like the NFL did with Super Bowl. Be able to look at production, pre-production, post-production, all these use cases. It's a whole market that didn't exist pretty much a year ago, and all of a sudden has blossomed out of nowhere. And the reality is that these workflows, these studios, we've worked with NBC, we've worked with Amazon Prime on producing different live events and so on. They need broadcast quality features with consumer grade workflows. And what that means is they need to be able to do what they could have done with much more expensive broadcast quality equipment in studio, but been able to do it from home on a laptop over a consumer grade network connection, be it their local ISP, be it local software, local hardware, and using the web browser, which is the most consumer grade piece of equipment you can think of, right? And they're trying to emulate these multi-million-dollar broadcast studio workflows using this consumer-grade workflow. It's such a crazy evolution that's happened, and it's been accelerated by what's happened in the world in the last year. And I find that quite fascinating. So how do we do that? How do we add broadcast quality features into consumer-grade workflows? You know, a lot of the streaming industry has done that already through a lot of our hardware encoders. You have high-end $20,000, $50,000 hardware encoders, and you've got others that are $500 or $1,000, right? Like the Video from Teradek, or, you know, Matrix Monarch, and, you know, all these different devices that have different price points and enable us to do it. But to do broadcast quality features, we need to build network resilience. One of the ways that WebRTC is doing that is through SVC, scalable video coding, that I'll talk about here in a bit. We need content protection. Like studios, it's notorious, right? What happened with Sony with the that Korean movie, right? Where it was leaked because one of the vendors, you know, they were able to grab a pirated version of it, send it out. How do we do end-to-end encryption to actually protect the content so, you know, people can't come in and take those streams out, like what's happening with Zoom and what's happening with a lot of consumer-grade products that were never built for broadcast, right? How can we add broadcast quality like HDR? We have an implementation that we're working on with Apple TV to add HDR quality, and that paves the way for things like Dolby Vision, like within WebRTC. Like, how crazy of a concept that would be. And we need real-time encoding, and we need codecs that are future-forward codecs that can do that. And AV1 is a really, really great example of that. And we're going to talk here about AV1 in just a bit. So I have a question here from Eric Hertz. And he goes into a lot of detail here, and I know Eric from my streaming history. He says some reluctance for adoption stemmed from concerns about Google changing Chrome and breaking downstream applications. Very, very, very true, actually. It's a very good point, Eric. For example, when Chrome 47 changed how it handles ICE changes, some of the WebRTC P2P vendors, and so on and so forth. This is still a concern for me. So Eric, you made a perfect point when it comes to the right place, right time. Is with WebRTC now being a standard. Look, technology is technology. Zoom just crapped out on me on this call. But as a standard, Google can no longer make changes if they want to follow IETF and W3 standards. They have to follow the WebRTC 1.0 standard. So Millicast will follow that standard. Our SaaS layers, application layers that are built on top of us, will by default follow those standards as well. So if you do go and you follow a 1.0 standard, which is where WebRTC is right now, in theory, it shouldn't fail. So I think that sets us up for the groundwork for browser vendors not having the control to change those things unless you use a beta version or alpha version of the Chrome or different browser builds. But that is a very interesting point, that I think it created that negative connotation because in a way it was because this free-for-all. And that free-for-all is also part of how it's still handled at the signaling layer when it comes to WebRTC. And that's what leads us into WIP, which I'll talk about here in a couple of slides. But let me first talk about AV1, because I think AV1's extremely exciting. AV1's not new. It's been around for a while. There are people who have built it into different workflows and different solutions. Of course, AV1 stems, in a way, it's kind of like VP10. It stems from the VPX codec that came from the On2 days and so on. And I think, as most of you know, you have the H26X codecs that I won't even get started on the licensing issues with H265 and HEVC and everyone's custom implementation of that. And it's a bit of a nightmare. So, you know, the nice thing about WebRTC, it's agnostic. It doesn't require you to use any particular codec. The ones that are most commonly used is H264 with OGG. A lot of people use that. OGG is the standard codec used inside of WebRTC. But, and what that enables is if you do that, you can then just grab that out of RTMP and repackage it into WebRTC. If you do that, it can add a little bit of latency, very, very little with our product, like usually only a frame of latency because we don't have to transcode anything. We just have to, or we do have to transcode the audio. I won't get too deep into that. But anyway, what AV1 does is AV1 is royalty-free. It will be ubiquitous. It's flexible, better compression. It enables SVC, which is scalable video coding, that we'll talk about here in a bit. It has a very low footprint. Some people would argue with that, but a lot of silicon nowadays is being designed with AV1 already on chip and on the device. And a lot of AV1 is already being used. You guys, if you guys are using Netflix, Netflix is using AV1. All their stuff, all their VOD stuff is already encoded. So all the devices that we're consuming Netflix on, most of it, if I remember correctly, is all AV1 decode, whether it's on your Apple TV or on your browser or on your mobile phone. So AV1 is already extremely ubiquitous. It's already being used for a ton of different platforms. I think YouTube obviously uses it for a lot of their stuff as well. Where AV1 hasn't been used that much is for real-time encoding, but that's changing, and I'm going to talk a little bit about that now. The amazing thing about where AV1 is going is that the idea of scalable video coding, it completely flips everything on its head when it comes to how we currently handle poor network conditions and quality, adapting quality to those network conditions for an end user. With adaptive bitrate, like I talked about earlier, we send one stream to Wowza or Elemental or any origin server, and that origin server will create the transcoded outputs, put them inside of a file in HLS, and then the player, whether it be JW player or video.js or whatever, will detect the bandwidth and switch those chunks to different bit rates. By doing that, like I mentioned, you break the end-to-end encryption. You have to have a lot happen at the origin server to be able to do the ABR. What scalable video coding does is you send one stream. The codec itself has the intelligence to be able to adapt within that one quality, that one stream, without ever having to transcode. It has the intelligence to be able to come through your origin, through Millicast or through any other WebRTC, come out to the playback, and the player then decides, I have the data inside of this, and I'm going to scale and change the quality inside that SVC stream and that SVC codec to be able to play that back to the end user. So there's no transcoding that ends up happening. A lot of people are doing either the transcoding layer, or a lot of people doing WebRTC now through simulcast, where you're sending a high quality, medium quality, and low quality 3 streams out from your source, and then you're repackaging that and sending that out. And that's a pass-through. That does allow you to have end-to-end encryption because you don't end up transcoding, but it means a lot more upload at the source level, and it's just not built for the future, and SVC is. And SVC is also available, it's codec agnostic. It's being used not just in AV1. AV1, the thing about AV1 is that SVC is enabled by default, but it is also available inside of H.265. The crazy thing about AVC as well is the amount of bandwidth it saves us for the comparable amount of quality. That part is the amazing part, is not only are 5G and our local internet connections getting more and more efficient, we still suffer from quality issues. So anything that optimizes the encode of the video is just going to optimize that even further to help us get into 4K, 8K, much higher features, be able to do a lot more with the bandwidth that we have. And it reduces cost, right, when it comes to the amount of bandwidth we end up using across networks and egress. And AV1 innovation is driven by the entire video ecosystem. There's been buy-in from the Alliance for Open Media, obviously, is running this, and AO Media has got all the major browser vendors involved, a lot of major hardware and software vendors involved, and here you see just a list of everyone who has embraced AV1 and is building that into their workflows. And this is why this is the perfect storm when it comes to talking about WebRTC, the standardization, and AV1, is the adoption timeline. Like just 6 years ago, AO Media launched, and here we are in phase 4 in 2020. AV1 was enabled on, AV1 enabled devices was available on all modern silicon. So every major mobile device going out, a laptop going out, Internet of Things devices going out, is built with the functionality to both encode and decode AV1, depending on the resources available to the machine, which means browsers, hardware, content, commercial tools, devices, all of them can actually enable AV1 workflows. So that leads us into where are we now, kind of. It's still the future. This is why this isn't the future section. We have one of our absolute rock stars at Millicast, Sergio Murillo, who is actually the guy who got me into Millicast. Him and I had mutual friends in Spain. And he is the author of the Meduse media server, which is open source and a lot of the technology we use inside of Millicast. But he has got what we think is the world's first workflow of AV1 real-time encode inside of Google Chrome, inside of the browser. And he was able to do this by grabbing the upcoming Google Chrome Canary, which is M90, the M90 builds, and building or compiling that with the functionality to be able to embrace AV1 with SVC in browser. And yes, this first version is not full 1080p, 4K, 30 frames per second. It's a bit of a lower quality version, but it paves the groundwork for AV1 real-time becoming a reality in browser. And by the way, this wasn't running on some beefy, server workstation. This was running on a consumer grade MacBook Pro, so a laptop. So that's quite interesting, the fact that AV1 real-time is now. Like, it's not, we should be building solutions on this now because it's going to be available when M90 gets released here in a few weeks. So the amazing thing about this is what this enables is AV1 and SVC enables a workflow that doesn't re-encode. There is no re-encode of the source. We encode AV1 SVC, we send it through WebRTC, and the ABR, what we consider adaptive bitrate, it's not truly ABR, it happens center side. There is no intelligence at the origin level, at the server level, at the platform level. It's the native WebRTC player inside the browser or the device that decides which, based on the bandwidth you have available and the CPU, which of the versions of and resolution am I going to play back? And that workflow is revolutionary. If you know anything about streaming and you've been around for the last 10 years with the way things have been done, this is revolutionary. This is going to change everything when it comes to end-to-end encryption with not having to touch the encode once it gets encoded. There is no double encode. It means quality gets retained. All the features you build in at the encode level are retained throughout the entire workflow. Like, how amazing is that? The worst thing that can ever happen with video and audio is the re-encode process, plus it adds latency. So I'm extremely excited about this. And if you want more information on this, down here at the bottom, there is a link to, I hate how Zoom puts this thing here. There's a link to, here, I'll do the one from Millicast. Where is it? Here it is. So Dr. Alex, who's our CEO and CTO, has a blog on this, but we have one on our Millicast site that talks about much more technical detail on the real-time AV1 SVC and how it unleashes the true power of WebRTC. And if you take anything away from this session today, it's this. This is what will allow us to build the new generation of streaming solutions, because it completely changes the way we're doing things currently. Kimberly's asking a question here. How does the AV1 SVC work when you want to record it and keep it as a VOD? So, good question. You can, of course, record locally. We can, that's a good question. I'm trying to think how we record at the server level if we can't unpack the encryption. Before we get too deep into that, Kimberly, we're not even there with the encryption piece yet, which is a funny part of where my presentation is going. I'm selling you guys an idealized version of where we're going. But when I talk about the future, and I say the future is now, AV1 SVC is now, end-to-end encryption in WebRTC is now. So yes, good point on the recording side. You've stumped me there. I have to talk to my team and see. Much more intelligent people can give you a better answer to that. But I'll come back to you on that for sure, or send me an email.
Hey, Ryan.
Yep, Eric.
Sorry to interrupt, but it seemed like a good place to do that. A couple of people have mentioned that links that you posted earlier to a couple of earlier other presentations you did elsewhere, they're having trouble getting those links to work. So, now may not be the best time, but before we close off today, if you could repost those links, that would be helpful.
Absolutely, I will do that. And what I tried to do is remove all the ancillary things inside of PowerPoint here. So I removed the HTTP and the links might have got broken in the hyperlinks. It's probably what happened. But yes, I can definitely share that. A great resource to go to, WebRTC by dralex.com. Just go there and you'll see most of the blog posts of what we're talking about here when it comes to end-to-end encryption, AV1 SVC. The one thing I really love about what the mantra is at Cosmos Software and Millicast, kind of the companies I work for, is we have a mantra of everything is in the public domain. everything except our true proprietary IP. But we contribute a lot to open source projects. The OBS WebRTC project is completely free. The WebRTC contributions we've done with IETF and W3C are all to drive standards. The AV1 involvement that we have with AO Media is all to help contribute and give back to the industry as a whole. There is no proprietary agenda. Like, all of this helps every other WebRTC vendor that's out there, you know, and that I like about what we do. So when you go to Dr. Alex's blog, WebRTC by dralex.com, everything you'll see is with that in mind. And that's something I like about the way he does business. And I highly recommend it. So yes, we're more than happy to have an open door and share all the tools and tips and tricks that we use when looking through all this. So let me continue on. Let's talk about what Robert Reinhardt was talking about earlier, which is, and to a point, what Eric was also talking about earlier, which is standardizing WebRTC. So one thing, there's been kind of a standard that's been happening and definitely is happening now with WebRTC 1.0 being, you know, solidified. We've created, this is it, guys. This is the standard that we all have to follow as browsers and devices and vendors and technology providers and all that. That's great. But there's still one layer of WebRTC that's still left up to different vendors, technology vendors, how they want to implement it. And that's the signaling layer. How you create a handshake with a WebRTC device is kind of left up to different platforms and different technologies. And that's a bit frustrating because what ends up happening is everyone has a different implementation. Some people do it in one way, some people do it another way. The way you contribute and you create a connection with a WebRTC platform, whether it be Twilio or whether it be Janus or whether it be Agora or whether it be, they're all different. So what Dr. Alex has tried to do with his team is once again contribute to the standard and make it part of the WebRTC standard, is create a signaling layer that uses HTTP, not anything else that could have issues with NAT traversal through a network. Let's use the most ubiquitous protocol out there, HTTP, how we access the web every day, to create that handshake in between one internet connected or one WebRTC connected device and another. And where it creates the best solution for is for encoder vendors. How do we get Wirecast and vMix and even OBS and you know, LiveX, is it? XLive, so from a software encoder perspective. How do we get all the hardware encoder vendors? Like, I remember all these guys that I've worked with, Matrix and Osprey and Teradek and Haivision and, you know, like Harmonic and Elemental. And how do we get all of them to jump on the WebRTC bandwagon? Well, in the past, it's been hard for these encoder vendors to do because of the fact that the signaling layer was just left up. And so every time you want to integrate with a WebRTC platform, you've got to build in a different kind of bastardized version that they've decided is the way they want to do it. The way that WebRTC communicates over the media channel, the media transport layer, is the same for everyone. That part is not different. That's part of where the standard's at. And there are people who have also bastardized that version of it, unfortunately. But the reality is with WebRTC 1.0, that will become standard. So that is now set in stone. But the signaling layer, WIP tries to fix that. It tries to make a way for all of us to do a handshake in the same way, not a fist bump and not like you know, we all are going to handshake the same way when it comes to WebRTC. That means that Teradek, who we've been in talks to build WebRTC functionality into, Videon with their Edgecaster, BirdDog that makes NDI-enabled devices that now also embrace WebRTC. We've been talking with all these vendors about adding WIP and adding WebRTC stack to their devices. It hasn't happened yet. The closest to it is BirdDog. We do have, BirdDog does NDI, and they have such great products. They have like these PTZ IP cameras. They've got all different kind of SDI and HDMI capture devices that allow you to capture, communicate over NDI. They've built an NDI cloud that is, you know, if you guys don't know NDI, it was made ubiquitous by NewTek, and NewTek was using it as a way to share things within a network, you know, graphic layers and different products and so on within a local network, or at the very most a wide area network. Well, what BirdDog's done is create a cloud so we can connect to our NDI enabled devices to the cloud. You connect your IP camera or your NDI enabled encoder to the cloud. And then from the cloud, they've added WebRTC that communicates with Millicast as an ingest. So we have worked with them on creating that layer, but WIP is still something that needs to be added to that. We've done that in a different way. So this time to make WIP standardized and make it a way that we can all communicate when it comes to contribution isn't pushing a proprietary agenda. WIP was developed by Cosmos, but we're not doing this to sell more of our, I mean, yes, we are, but we're doing it to make WebRTC ubiquitous on every device. And this is one of the kind of stopgaps that is needed to kind of get through. And the primary place it has to be done is with encoder vendors. The more ways that we can get solutions into or content into WebRTC, the more it makes WebRTC a de facto standard for delivering stuff. So if one thing I'm going to ask from you guys in this entire thing is to go to these your hardware encoder vendor or your software encoder vendor and give them the feedback. You know, like I've worked with Wirecast for years. I'm going to go to Telestream. I'm going to tell them, look, guys, build in WIP, build in the WebRTC stack into this. Immediately, you're going to be able to stream to Millicast, to Janus WebRTC. You're going to be able to stream to Medu's server, which is an open source server that people, and Janus is as well. So many other platforms have built on top of those. So they already have WIP enabled. So an encoder vendor right away, boom, you can go straight into all these platforms that already use these media servers as their base for WebRTC ingest and processing and packaging and so on. So that's quite an interesting concept. And anyway, that's all I'll say about WIP. And hopefully that was clear. I have a tendency to trail off and go down rabbit holes. So let's get to, I think this piece is one of the most critical pieces and differentiators that's truly happening in the industry. I've talked a lot about end-to-end encryption and security protection and privacy concerns and all this. And the reality is we put a lot of trust into all of our technology providers. We put a lot of trust into Zoom. We put a lot of trust into, you know, any media server, into any voice over IP provider. But the reality is almost all of these solutions, especially when it has to be packaged or recorded or transcoded or manipulated in any way, that manipulation means that true end-to-end encryption never happens. You can't guarantee that something encrypted between one person and another has never been seen by anybody else. You just can't. There could be someone who is your, you know, provider, like a Zoom. There's a data technician at Zoom who will get onto that call and be able to see it because the encryption has had to be unpackaged for them to add other functionality into that workflow. True end-to-end encryption has not been able to be a thing with ABR. It just hasn't. Yes, you can encrypt the contribution from RTMP by adding RTMP-S with security and SSL. You can then unpackage that at Wowza or at the origin server and then re-add different encryption and DRM, digital rights management, things like that to protect content. But Wowza's had to decrypt it. It just has had to be able to add all that functionality into it. So when people talk about the industry, about true end-to-end encryption, and I'm one of them, my head was in the sand. I sold it. I'm like, yeah, we have, you know, encryption, you know, ingest output, but it's not true end-to-end. And what you're seeing with WhatsApp, with what you're seeing with technology being used to create revolutions, you know, all these platforms that actually, like Telegram, that add true end-to-end encryption are being banned. And you know why? Because someone's individual privacy is put above anything else. And I think it's a very good thing to follow in media. As technology providers, as all of us who are building streaming solutions, the other really interesting thing about this is if you never actually see the media, you never actually unpackage it and repackage it, you don't have any liability. You can have someone do whatever they want over your platform, and that can be good and that can be bad, but the liability goes away. And liability is a huge issue, especially in the United States. There are many CDN providers, there are many OVPs that restrict what kind of content you can do over that. But there's so many vertical markets that us as streamers serve and we make money at. And they're markets that are legitimate. Maybe they have, you know, things aren't considered religiously appropriate and so on, but there's still things that are provided by the streaming industry. So I'm talking there specifically about adult entertainment. Most huge cloud vendors don't offer, or CDNs don't support any kind of adult entertainment. And they don't because they don't want to open themselves up to any kind of potential ethically ambiguous, investors don't like it. It's an issue. It's a big kind of taboo. And when we go to IBC and we go to NAB, everyone knows that the biggest adult entertainment conferences are right around those two conferences, but it's a dirty little secret that nobody talks about, but it's a multi-billion-dollar industry. And for them to have true end-to-end encryption, live cams and things like that, it's great for the sensitivity. It's something that needs to be there for the sensitivity of the users of those platforms. So I'll stop talking about adult entertainment and I'll talk about more legitimate use cases: healthcare, telemedicine, people's privacy. How can we follow HIPAA regulations, which is the standard body in the United States? How can we truly offer HIPAA when we're having to do ABR? We don't. There's not privacy for the healthcare worker who's talking to a nurse, a remote nurse with telemedicine, who's talking to a patient, right? We're doing surgeries now in real time across the public cloud, the public internet. How do we truly have end-to-end encryption? Government use cases, all this government sensitive material, even just private conversations. I talk to my girlfriend remotely. I want to know that that's a private conversation and nobody can ever look at that. That is something that is the new generation and the new standard for streaming. And I don't think it's talked about enough. And AV1 SVC enables that. But where it hasn't yet been enabled, and it's not part of this standard, and we're definitely a standards-driven company, and so is WebRTC as a whole and AV1, is there still hasn't been a standard that's been embraced with how to add that end-to-end encryption. So there's the problem. I have an answer to my own question, which is rhetorical, which is secure frames or Sframes. And Sframes is once again another standard that's been put forward by Cosmos and our team to the standard committees for them to add secure end-to-end encryption inside of WebRTC that truly adds that end-to-end layer that's still lacking inside of WebRTC and truthfully is lacking inside of any end-to-end live streaming workflow. So this definitely goes above my expertise in WebRTC, but the links are here and I will post these links. And here is a slide that talks a little bit about how we do that without having to unpackage the video itself. And the way we do that is by not doing it at the media transport layer. I feel we do it through the data layer, right, that's wrapped around it. But don't quote me on that. And Dr. Alex is probably rolling his eyes at me right now on the call. But all I want to tell you is that this is something that we are building into our Millicast platform and that will become hopefully a standard and built into a lot of other WebRTC workflows as well. So Eric has another technical question for me. Can I deploy Medu's media server locally to split Millicast streams so I can reduce the number of concurrent Millicast streams that traverse my firewall? Trying to think of how you're trying to do that. Eric, let's take that offline. That gets a little bit more technical and we probably need to talk to Sergio about that to answer it. I don't want to give you a bad answer. Obviously with Millicast, we're a platform as a service. We make our money off people coming through our platform and using bandwidth and doing streams and so on. The one thing I love about everything you're going to take from this presentation, it's all agnostic. It's AV1 SVC, S-Frame, everything I've told you about WebRTC and the commercial offer or the commercial opportunity that's there and all the markets that are going to be affected is true of any WebRTC solution that's out there. And there are many of which you probably already know about. So I think this will arm you with the good information needed to go and ask questions like Eric's asking of how can I optimize my workflow for what I want? How can I use it? And me, myself, I don't always have the answers. I can get those answers from the right people who are definitely more deep on the engineering side than I am. So let me circle back to you on that, Eric. All right, so let's kind of wrap up and let's get into the actual hands-on stuff, which is what I enjoy the most. Let's talk about what we're currently limited by and how we're going to mitigate that to truly take WebRTC where it needs to get to. We've talked about Millicast, WebRTC already being web quality, right? And it's already kind of pushing the limits of what a lot of people have interpreted as web quality, where, hey, I can't control the bandwidth, or hey, I can't add deeper, 10-bit or 12-bit or HDR or all these different features, I'm restricted by WebRTC as a protocol. Well, what we do is we don't develop the browsers. And the reason you have those restrictions is because the browsers restrict you. The reason we've been able to get AV1 SVC working is because we have a badass working for us who's able to take the raw Chrome code base and recompile it to get it and tested before it's even available publicly as a solution. So that allows us to kind of push the boundaries of what we can build, the support we can build inside of Millicast as a platform. The other thing that we're restricted by is the browser is used for both broadcasting and for player in probably the vast majority, definitely on the player side, the vast majority of your users are going to use the default browser in their device, Safari on iOS or Chrome inside of Android or whatever, right? To be able to consume it. But if the browser doesn't support HDR or 10-bit, you're restricted by what can be done in WebRTC as a broadcaster. How do we push the boundaries of what can be done in WebRTC? Well, the answer is a native app. And so what we've done is we've developed Millicast Studio, which is a native broadcaster, encoder, and player decoder that is available on our GitHub repository on the one I shared earlier in the Q&A window, and I'll share it now. That is a precompiled build that allows you to add features that you can't do inside the browser currently. So inside of Millicast Studio, we're already enabling AV1 as a real-time encode inside of that studio. It can use a Blackmagic physical device as a capture device that's plugged into your workstation to grab an SDI feed, encode it on the hardware itself, and then be able to encode that to AV1 and send that over WebRTC from Millicast Studio. So what Millicast Studio really allows is a workflow that you can't even really do with OBS because we don't have control over the roadmap for OBS. It's an open source project that we don't own. We own the fork, which is the WebRTC, but not the original OBS project. So what we decided is, or Dr. Alex decided, hey, let's go and let's build our own Millicast Studio and our own Millicast player. So we can do things like 444 true color. We can do things like 10-bit and 12-bit. We can do things like HDR and even Dolby Vision. We can do 5.1 and 7.1 surround sound. We can do things like Sframe, like end-to-end encryption that currently can't be done in the browser because it's not part of the WebRTC spec. We can do things like forensic watermarking, which can't be done on WebRTC yet. We can build in AV1 SVC to add the resiliency layer. We can also, on the resiliency side, look at much more when it comes to the sender and receiver analytics than we can inside the browser. And we can also build our own custom apps for different devices. We have an Apple TV implementation that we ported WebRTC to the Apple TV. So if you want to do a full HDR 10-bit end-to-end for like high quality thing, you can do it from Millicast Studio ingest and capture and play it back on a beautiful 4K screen with an Apple TV supporting those features. And that's the vision and the roadmap we have for Millicast Studio and Player. We're not trying to replace a proprietary workflow. That's not our goal. What we're trying to do is push the boundaries of what will become standards inside of WebRTC. And the only way we can do that is through these custom apps. And these apps are available for people to go and build their own solutions on top of as well. We're always going to add an SDK that adds the base layer, and then you can add the white label top of it to go and build that for whatever vertical market you want to go after. So that's our view for Millicast Studio and Player. And the remote production space specifically, they care about broadcast quality. They care about, they're using Zoom right now to try to show the next 4K stream coming off of Warner Brothers release. How is Zoom gonna, you can't control the quality in there. Nobody can see the color grading that's happening in real time. You need solutions and you need apps that support those workflows, right? Trevor has a question here. Can you elaborate on forensic watermarking? Is this the bitstream watermarking technology being promoted by other vendors? Great question. I'm not going to go too deep on this, Trevor, but if you do go to Dr. Alex's blog, he did a lot in he's an educator by trade. He's been involved so much in research and research at Harvard and a lot of other very notable universities doing research on things like watermarking, things like advanced VR and things like that. When it comes to forensic watermarking specifically, there is an issue with latency. Like there is no forensic watermarking solution out there right now that can give you the solution you need without adding at least a half a second of latency on top of the latency you already have through that workflow. But we are working on things in our roadmap. To be honest with you, it's probably not going to be until early next year that we get to that from an engineering perspective. But we do have the brightest minds, or put it this way, we have the minds that can build that into our platform as a service. But there is a blog talking about forensic watermarking, and if not, we have a white paper on it that I will send to you if you hit me up at ryan@millicast.com, where it goes into a lot more detail about that. And watermarking is interesting. Like a lot of people are doing watermarking now at the player side. You know, actually embedding it inside of an encode when you transcode at the origin layer. It's, once again, you can't do that, right? If you want to do end-to-end encryption. So what people are doing is they're actually doing it at the player level. They're decoding the video and then they're adding, you see kind of the random user-generated unique ID. So if you did a screen capture, you did everything of that, they would be able to track that back. So that's not forensic watermarking. That's kind of a, this kind of in-between solution that can be done at the player level with building a player SDK inside the browser that can add that layer. The forensic watermarking obviously is a lot deeper, right, in what it needs to do to be able to do that so that it can't be removed from the video itself. Whereas a lot of these other things you can do by putting a little black box on it and adding a little bit of delay to do that. And people do that through OBS and other things, unfortunately. But anyway, I'll digress. All right, so with that in mind, I actually want to give you guys an end-to-end demo of Millicast Studio. And before I do that, I want to pull up the browser and I want to show you guys the GitHub repository where we're at. So if you go, it's a little confusing because we have our parent company Cosmos, which has been around forever and contributed to WebRTC and AV1 and so on. Most of our projects, open source projects, are in that repository. We also have another one. Oh, where is it? That's a Millicast that has some Millicast specific stuff, but the Cosmos GitHub is here, and I'll go ahead and put this in the chat real quick. And if I come here to Millicast native public, and if you just type in Millicast on GitHub, you'll see this. Right here you can see this is Dr. Alex. This is his baby. And what Millicast Studio is the full app. And the checkboxes are what we already have. The empty checkboxes are what we're looking to build as we evolve this. And I'll just say, we launched this in December. We're currently in a beta with this, and we're hoping to launch kind of a fully working production level version of this by the time, probably by the end of March, April, I think. But it doesn't mean you can't take this now and go and start playing with it. So what can we do with Millicast Studio now? Well, we can do inputs and capture. We can do an encoder mode for a single stream. We are going to be building in a studio mode, which allows you to do multiple inputs, do mixing, kind of like what you can in OBS. There's support for different devices. We've built in NDI by default. You don't actually need to run the NDI separate app. We actually do NDI by default in here. You can pull up screens and monitors and switch between them. We have support for the Blackmagic Decklink card that allows for both SDI and HDMI capture. We are going to be doing things for creating local versions for file readers. Oh, and also grabbing VOD files and pulling those in. Things that we want to do eventually as well is do mixing and so on and so forth. And then what we have here is the actual connection to the Millicast platform. So we have a connection through the REST API that allows you to, of course, create that handshake with WIP and be able to stream directly to Millicast with that WebSocket connection and so on and so forth. And here is a breakdown of all the different codecs that we're already supporting for both the codec and the quality layer. And you can see we have plans to add a lot more when it comes to both AAC and Dolby codecs. There you go. So that's the Millicast Studio piece, which is the encoder. And then as part of the same solution, there is a studio loopback that allows you to see the stream coming off of Millicast. So you can see and measure the true latency and use it almost like a studio monitor for seeing the playback. And that's what gives you this different analytics control. And there's a lot of things we want to do to add all kinds of kind of broadcast quality features to be able to give you more data than you can currently get in the web browser. And hopefully everything that you see here on our roadmap will make it into the web browser over the next couple of years. But someone's got to push the standards, and that's what we're trying to do within these apps. And then we have a standalone Millicast player. The reason we have a standalone version of the Millicast player, it is built into the studio, but we have a standalone version because we port that to different operating systems and devices. So that's what we have in the way of an Apple tvOS implementation. And I'll show you guys that video in a bit. And we have a iOS implementation as well. And we're currently working on an Android version that I think will be ready very shortly. You can see it's already here. And it's available for Windows, Mac, and Linux. The great thing about this is that, let's say you have a live streaming customer that needs to, measure the latency and see it. They can set up, kind of workstations and machines to be able to see that side. The other way to look at this too is you could set this up as a decoder. There's a lot of encoder decoder workflows with vendors like Videon and Haivision and so on, that they encode broadcast quality, they transmit over the public internet, then they bring it down into a decoder. The Makito encoder and decoder is a great example. Decode and then play that back on a nice high resolution monitor. That layer over the public internet is the layer that really can't be controlled, right? Like that's the layer where SRT is trying to be put into place and all that. But what this Millicast Studio and Player allows you to do is to build that encode decode layer that allows you to do that workflow where you can send high quality streams and play them back in remote locations. Great things for studios. And we're working with like NBC, and we're working with a lot of big broadcasters on that exact use case. All right, enough about that. So to actually download the releases is if you come into a project in here, you come over here to releases. There's two tags. If I click on that, you see there's an alpha D build here. And if I click on assets, here you can see there is a player. This is a standalone player for Mac. There is a full studio for Mac. There is a full studio with the embedded player for Windows and the source code as well. All right, so I'm going to go ahead and pull this up. And inside of here, you can see it's very, very bare bones UI. And the reason for that is we're trying to build the actual underlying layer that gives you the high quality encode decode features and allow you to build whatever UI you want to go build if you know how to build on top of an SDK. You can also see all the other devices I can capture inside of this, very similar to what you can do with OBS or quite a few other software-based or even hardware-based devices. I can choose any physical device I have on here, my FaceTime camera, NDI video, and my OBS virtual camera. I can choose my monitor, right? And I've got my MacBook Pro monitor, and I've got my separately connected HDMI output. I can also do what's called, I think this was called CSR or something like that, where you can actually grab the app window inside of a browser like Chrome to grab just the app window itself. So actually that works for both Chrome as it does for any app. So if I have PowerPoint in here, you can see I can grab my Finder window, I can grab my Zoom window, and that means you can just grab that particular application, kind of like you can within Zoom, without having to do a full screen share. So this is a great way to capture exactly what I want from the output of a device as my source. A lot of people are doing really hacky workflows. Zoom is a great example. They're wanting to do this kind of interactivity where they have multi-stream. They're pulling up on a monitor, they're capturing the HDMI output, and then they're pulling it back in through another re-encode. How many times is that video getting re-encoded, right? From the original encode to Zoom, to you capturing it, to then capturing it out of a device into another software encode. Oh my God, it's getting encoded 3-4 times over. It's such a horrible workflow. What we're trying to do these days with town hall meetings and conferences and all this with Zoom and Microsoft Teams, it was never built for that. It was never built for live streaming workflows. These tools we're trying to do are trying to solve that, right? All right, so let me come in and choose my native NDI output. You can see there it is. I can also choose my NDI audio, and I can choose my video constraints. Now, because it's forcing this to whatever NDI is sending me, which would be a 1080 output. And then I can also choose what my audio player will be when I choose to loop back, right? All right, so great. I'm gonna start the capture. Let me grab my FaceTime camera. The nice thing about this is this does give me extra choices for what quality I want to do. You can see we're currently limiting it in here, but I'm going to do 1280 or 720p at 30 frames per second. I'm going to actually grab my microphone and I'm going to start capture. And there you go. There's my video. So I've done that, and it's over here. So my monitor's here. So, all right. So I've done the capture, right? So now I'm going to do my encode. I can choose H.264, or I can also do AV1 real-time, VP9, VPA, right? So we have enabled these workflows with Millicast. So you could go AV1 end-to-end, Millicast Studio into Millicast platform, into a Millicast player, or even into a web browser and decode, because AV1 decode is available in the browser. So you can already do a full AV1 workflow with this workflow. But for now, I'm going to keep it H.264, and I'm going to do my Opus audio codec. So great, I'm doing the encode there. And I'm going to publish. So just like I did with OBS, I'm now going to jump over to my browser. I'm going to come into my live broadcast. Oh, there we go. All right, so let me go back. Here's my Millicast Studio. I'm going to come into the API, grab the stream name, put that in here, and grab the publishing token. That's it. That's all I need. The other thing I was going to say about WIP is that's another piece to WIP is, you know, right now when you connect an RTMP encoder and you integrate with an RTMP encoder or an encoder vendor, they've made it standard to have just a URL, stream name, password, and that's pretty much it, right? That's what WIP is trying to do too, is trying to standardize it to have just a URL endpoint. That's another real piece to the WIP protocol and standardizing that for different encoder vendors. All right, great. So that's all there. The publish API URL is already in there. So I'm now going to connect. I've connected it. You can see down here in the bottom right, it's saying capturing and connecting. I'm now going to start publishing this. So if I now jump back into Google Chrome, here is that hosted player path, and I'm going to play that back in browser. So I don't need to use a Millicast player. I can use the browser natively inside of Chrome or any other browser. I can even pull this up on my mobile device. Absolutely no problem. And in fact, let me do, wow, that'll get me derailed. One thing that we are doing, because this is still an alpha build, is we're overlaying our Cosmos software watermark, but that will eventually go away, obviously, as we create a public version of the SDK. So there's the playback. Now, what I want to do is not use the web browser. I want to show you guys how I'm going to use this to monitor the output. And what I will do is I'll share this viewer inside of the chat window so you guys can go and see this. And we should be getting audio in here as well. By default, the mute's on. I'm going to do it briefly to just listen and put up my audio. And I can hear that playing back on my device here. Yeah, there it is. So yeah, the audio is working. So you guys should hear me both through Zoom as well as through your browser. So pull up the viewer, but then just, you know, cancel it quickly and then come back to Zoom. The second piece I'm going to show you now is what I think is really cool, which is using this as a monitoring station. The biggest problem in streaming, as you guys probably know if you have any experience in streaming, is trying to diagnose issues and triage them and troubleshoot. So what's happening now is you see on the left is my remote stream that's adding the watermark and coming off of the Millicast platform. And on the right is the source encode on my local device. So my local stream on the right, my remote stream. And if you see here, this is the platform, how quick it is. We're talking about, I mean, that's got to be 200 milliseconds or something to that effect. I can pull up the local stream and the remote stream and pull up a lot of information on this. Not just that, I can double click on the frame rate, the video packet loss, and see where there's been issues either locally or remotely. That kind of visibility is extremely hard to do in any streaming, let alone WebRTC streaming. And I think that's why we're creating these tools, is we're trying to create tools to add more visibility at a deeper level into what can be done with WebRTC. And when issues do happen, because, you know, technology sucks and things happen, how to diagnose those issues. And I think that's something that WebRTC needs to get to, that some other technologies have already done it. We've had the proliferation of technologies like SRT, Zixi, and obviously they have built different layers of resiliency over the last 10, 15 years that WebRTC needs to actually learn from and get to as well. And that's what a lot of this tool aims to do. All right, so that was a quick workflow there. Let me come back in. I do have a question here. Tim's asking, can you comment on dealing with packet loss and jitter over the public network with WebRTC. SRT, for instance, attempts to deal with this. How can or does WebRTC deal with it? I've seen forward error correction, or FEC, discussed in the context of WebRTC, but not sure if it is really supported. So, I mean, there's a lot of things we do, especially with our parent company, Cosmos. We have this tool called Kite, and if you do go to the Cosmos repository, you can do a lot of things when it comes to doing some real testing of WebRTC platforms. You can hear some Kite sample tests, and then there's the actual WebRTC, I think it's under WebRTC project, WebRTC/Kite. So here we start getting a little bit into the weeds on technology. But what Kite is an open source test engine designed to test WebRTC interoperability across browsers. With our parent company, Cosmos, what Cosmos enables, and we've stopped doing this because we focused very much on Millicast and building out Millicast, but we do use Kite testing for our own resiliency in our own platform. And what it allows you to do is actually come in and do a lot of what you're talking about, which is trying to add more measurement and testing for all these issues that you could potentially have with packet loss and jitter and noisy neighbors and so on. I'm trying to find where our here it is, interoperability testing. So there is some very some good information on this page. It gives you an idea of what the result output analysis is. There's a lot of extra add-ons that are there. So I encourage you to go there, and the GitHub projects are a great backup to that. That is a really good thing. From just like a tool perspective, there is a tool that I use just as a network test. And this is rtctest.com. So this is a great way to kind of just test WebRTC on your device, whatever you happen to be on. And here you can actually send packets across, change the frequency, duration, frames per second, so on and so forth. And you can see it runs that off of a server that looks like it's on EC2 on AWS. And here, this will allow you to start a test. And it pretty much just kind of does what bandwidth testing tools kind of do for your ISP, where it sends packet out, coming back, and you just kind of measure the progress of what's sent, how much time it takes, and what's received, and the packet loss you have. Now, trying to, us as a WebRTC CDN and platform provider, we've done this Kite testing, and we do it in order to really add that level of resiliency. We use a tool called Grafana, which is a way to actually monitor all of our entire architecture network in real time and know when there's peaks and spikes and things happening on servers. And I see here, Christian Thomas, this is another one I was going to mention too. He's mentioning CallStats, which CallStats is another, oh, come on. Oh, my machine's running so slow. So CallStats is another great way to look at this. And I believe we've worked with them, if I remember correctly. I'll have to check with our engineers, but another great way to look at additional information on WebRTC resiliency. So let's talk about interactive media. I think this is a part that's really compelling. So there's this kind of proliferation of watch parties, right? The idea that we could be watching a linear stream, say the Super Bowl, but we want to watch it with our buddies all around the world that we haven't been able to get together for any reason. This is also happening not just with live content, but with VOD content like Disney Plus. Disney Plus has hit, 100 million subscribers? Unbelievable what they've been able to do with owning their own content and do that. And they've built their watch party. Hulu has done the same. Netflix, I think, is launching something. And ultimately, the way that you stream that linear stream, you could do it with traditional streaming workflows and CDNs and do that. And that could even be latent. But the watch party side of it needs to be something that needs to embrace real time. And the best way to do that is WebRTC. And there's already quite a few solutions out there. So the idea of bringing in that source, being able to stream that linear source to N amount of viewers, by N I can mean thousands or millions of viewers, but then also be able to spin off a room to create a watch party that is protected, it's secure, it takes that first singular stream, but then creates an ultimately a peer-to-peer experience, right? That could then also stream to a certain amount of viewers. That's a very interesting way. And how do you do that with one intelligent URL? How do you create that ability to create watch parties and rooms with separate URLs? How do you create access control between leaving one room going into another, or going from moderator or host to passive viewer? How do you account for bandwidth, right? When you are pulling in a source stream, which needs to be high broadcast quality, but then the peer-to-peer WebRTC needs to be done in a separate way. And that all needs to be done at the platform level, right? Inside of WebRTC. And building that is not trivial. And you know, I've talked a lot about WebRTC, and as much as it is open source and it is an API and there's a lot of documentation and open source stuff, it's trivial to do a first build and get it working, like me to one person or me to a couple people. That you could do in a matter of minutes. It's scaling it and making it robust for thousands of concurrent streams and millions of concurrent viewers. There's only, and I would say modestly saying this, there's only a handful of vendors that are doing that truly at the global level. And I don't want to disparage anybody in the industry, but a lot of people who are saying they're doing WebRTC are doing the first layer of that and not doing true scalability. And that's where we get into talking about SFU and MCU and different media servers, and how, you know, a lot of traditional streaming vendors have one origin server that you spin up, and then you're able to then send out an HLS stream that the scaling layer is done by a CDN. Well, you know, there are no real WebRTC CDNs, or there are a few. So if you are a traditional media server vendor, you don't know how, you don't have the tech, you don't have the tech stack and the architecture to scale that millions of concurrent viewers through WebRTC. You just don't. You need a CDN to be able to do that. So that's when we start talking about how all that's intelligently routed. And I'll touch on that really briefly just at the end of the presentation. I'll just reference some of the more technical slides that I can share in a follow-up email as well. And if you're interested, you can email me directly at Ryan@Millicast as well. But all that needs to be done at the platform level to be able to enable these workflows, right? Now, the one part that really hasn't been done and really is the future, I feel, of streaming, is the idea of a stream party. And the idea of a stream party is pretty much what we're doing, what Zoom has hit on just by pure luck and timing and being right place, right time. Like, first of all, am I the only one who was like, why are people so amazed with Zoom? Like, all these other technologies have been doing this for 10 or 15 or 20 years. Like, why does Zoom come to the forefront, right? Like, Citrix has been there forever with WebEx, or GoToMeeting and GoToWebinar, and like, you know, all these different tools with Cisco and Citrix, and Adobe with Adobe Connect. And why did Zoom become the one? I just don't know. I literally don't get it. No support for native, really. It's all custom apps. They're just right place, right time, right timing, right? But what people are trying to do with what I talked about earlier with broadcast grade streaming workflows inside of consumer grade products, no better example of that is Zoom or Microsoft Teams or any of the ones I mentioned. You can't control a 1080p 10-bit HDR 5.1 surround sound stream inside of Zoom. You just can't. And not just that, you can't build a platform and take it to market on top of Zoom. There's no economies of scale. You can't white label it to your brand. Like, you're seeing so many, you know, healthcare gyms, you know, yoga studios using Zoom, but the reality is ClassPass and, you know, Move.gb, these kind of fitness providers that are SaaS products, right, for the fitness industry and health industry, they've wanted to add a live streaming platform because of the fact they're having to push everyone to Zoom, and everyone has to have different accounts. This is why Zoom's grown so much. But the reality is, it's not the right tool for what we're all trying to do. It just isn't. It was never built for that. It was never built to be a truly ubiquitous streaming, you know, workflow provider. And the interactivity piece is rudimentary at best. And the worst part of it all, it's not native to any device. Oh my God, I was using Ring Central yesterday on a call. Had to download it, had to install it. I felt like I was in 1999 installing custom SDKs. What a disaster. One of the guys had to restart his computer to get it to work. Why are we still doing this in 2021? This all needs to be built, but it all needs to be built into a platform that can enable it. And, you know, Agora is the tech stack that oh my God, I just spaced. I mentioned it earlier, that Clubhouse is using. Sorry, guys. So with with Clubhouse is this app that allows you to do that, but it's audio only right now. Nobody's really been able to figure out how to do it with video, how to scale it to thousands and millions, and add this two-way interactivity of scaling in between, right? So as we talk about interactive media, you know, this idea of a stream party is building this into a platform layer. That's what our idea is with Millicast. And it's up to you to go and build that into a vertical, whatever you want it to be, all the ones we've mentioned previously, right? We don't care. We're just going to create the underlying technology to do that. And I think there's going to be a lot of other WebRTC stacks and WebRTC CDNs and platforms that do this. And you know what? Amazing, because it gives you control over that broadcast quality instead of some third-party platform that doesn't give you control over security. A lot of people are not using Zoom because their enterprise doesn't allow it, government use cases, so on. So by being able to create something that uses an internet standard like WebRTC, it really creates a much bigger playing field, right, for all these use cases. So town hall meetings, conferences, webinars, concerts, education, late night talk shows, and there's so many others that will evolve, like this remote production use case. So the idea of how this works is kind of like Zoom right now, where we're using this and we're co-hosting, right? And you give someone become an active speaker. A server takes care of that, and then it encodes that together and sends a linear stream to a streaming media server that then takes care of scaling that to all the different viewers, right? So what can tend to happen here is these different co-hosts, let's say 2, 5, 10, it all gets encoded usually into one master stream that then goes to a streaming media server because that's easier to scale, right? The other way that it works with WebRTC is, yes, you send individual versions, but it down encodes, or it creates a lower quality version for people who aren't active speakers, or it does audio only. And you've probably seen this already with Google Meets and so on. So there's all this functionality that already exists in WebRTC to do this. But what there isn't is a way to package this together into a professional stream where you can send one master quality, high quality stream. Think of that post-production use case. You have all the producers, executive producers and directors and so on, all watching this master TV show or movie. And while they're looking at it in real time, that one quality needs to be the highest and everyone else needs to be put into a lower quality, right? How do you build a platform for the remote production industry and monetize it and take it to market on top of Zoom or Teams? You can't. That's what this is aiming to do. And the use cases are endless. The other piece is these passive viewers. Imagine the director of that film is like, you know what? I've had enough of this. I want to go back in and become the active host and give my feedback. Well, at any point, they can dynamically go from passive to active inside of this. Think about how you scale Zoom. A lot of people are having to do an RTMP out of Zoom or Teams or other products to go into a Wowzer or go into a place to package it and scale it through a CDN. Well, think about that. God, look, you've got this one product that can't scale to 5,000 passive viewers. So I need to send them an HLS through so it's two completely different solutions. How does a passive viewer become an active viewer? You've got to send them a Zoom link. They got to come in, you've got to upgrade them. And it's all through a native app through different disparate technologies. It's just, what a cluster. This is interactive layer needs to be built, and technology vendors need to build it. And we're one of them, and we're going to be doing it. And this is our biggest goal for 2021. What it looks like from a tech perspective is this, and I don't want to get too deep into this because I think a lot of you maybe don't care. You just care about what does it mean to me and how can I make money at it and how can I go build a solution on top of this. But what we're going to be doing is what you see kind of this middle layer, this WebRTC source one into a single ingest, into an edge network, a CDN that then scales that to millions of viewers. This is what Millicast is right now. And we do it very, very well. And we do it very stably. And we have a ton of customers that are using WebRTC end to end, or even RTMP in with WebRTC out. And we're scaling that to millions. And we're one of few that offers that truly at that layer, at that level of quality. What we're already building and what's being built and what customers of ours are already starting to build on top of is the idea of the watch party, the idea of the stream party, and the dynamic ability to go in between these, in addition to adding other interactivity that enables these viewers to interact with content like ads, like polls, like gambling, all these kind of things inside of this use case. The other thing that this slide identifies is these two ways interactions are great and it's needed, but we still need to have the ability to send this out affordably to passive viewers and have recording workflows for VOD. So you've seen the proliferation of restreaming networks, you know, like Restream is a big one. Also, you want to restream this to Facebook and YouTube and LinkedIn Live, depending on what our use case is. And an RTMP out needs to happen so that we go through this traditional workflow that all these other platforms support. In addition to also serving up HLS and Dash for VOD and being able to do clipping and all this stuff, right? So there's two-way, there's one-way, and there is, you know, file-based stateless files like HLS and Dash and so on. So that kind of gives you a good architecture of where the future is going with interactive media. And this layer right here that you're seeing is exactly what was built with Clubhouse on top of Agora. The only thing that they've done is they've done it in audio only. And nobody's really done that with video yet. There's the starting of this, right? And it's a lot more complex because audio, you're talking about low amounts of data. It scales better than video does, so on and so forth. Now, one example I want to show you is this is a call that I just did today with one of our longtime, most loyal customers, which is Megaphone TV. So I don't know if you guys are aware of Megaphone, but they provide all kinds of different products and services to broadcasters and streamers to add value to their streams. And they've been doing a lot of that on top of Millicast already with the WebRTC interactivity layer. Now, the thing I wasn't aware of until this demo this morning they gave me, and the timing couldn't have been better to give them some free promotion, is they launched this new product called StreamClick that's still in very, very early stages. But I saw a pretty damn good demo of this today that allows for the two-way interactivity piece. It's built on top of Millicast using our APIs. It allows people to interact through chat, through interactivity, through polling and so on, all native inside the web browser, all of it. Works on any device, any browser that supports WebRTC. And I actually, with their permission, took a video of this, their platform in action. And I'm going to pull up that video now just to give you guys a sneak peek of what that looks like. They've been able to really use our APIs to create very, very high quality streams. This is Colin Mook, who is the product manager working on the product. Here he showed how we've gone from a Zoom type use case or Google Meets, shown a 3-up format, shown a 1-up full screen format. Now he's gone back to the divided view. That's all available as a kind of a mixer that they've built on top of our API that they can pull in those WebRTC streams, be able to then choose which one is the primary at any given time. They've built this chat feature directly in the browser. None of this requires a plugin. It's all HTML5, CSS, WebRTC, and so on. This that you're seeing right now is a teleprompter. So many people are using the browser and they're having to look down at notes or so on. They built a teleprompter functionality that allows you to look directly into the camera as you read. You can see here, I looked a little rough this morning, by the way, guys. Oh my God, I had a rough night last night working on these slides. And then here you see there is an actual ad. This is an ad that's added through CSS. So it's all done in browser. And this could be done and served through an ad network and then controlled through your application level, right? Millicast doesn't do any part of this. We care about the underlying video tech, but this piece they've built on top of it. And here is an interactive vote that we ended up doing all in browser as well. All right, let me kind of fast forward through this a little bit. So you can see here, there's a few different polls they did. The amazing thing that they were able to do as well, and you see they actually could pull live Twitter feeds in. Where'd it go? So here you go, live Twitter feeds from different sources and use that to actually do the mixing in cloud. And I think this is the way of the future. I think ultimately the browser will end up becoming, it already has, right? With products like StreamYard and Restream. And I was part of a startup called Dazzle.tv in France that also looked to use the browser as the native way to produce streams, right? Currently, a lot of that is still done at, people think that web layer and the amateur layer, maybe not true professional broadcast streams, but that's changing. And that's changing with everything that I've talked about. So here we're seeing a sneak peek of the back, the admin, the moderator layer that's inside of this product. So here you can see they can hide the chat window for all viewers. You can see guests, you can upgrade them to producers and hosts. You have all these different scenes that you set up ahead of time. Here you can give the different guests. So all this kind of user layer they've built on top of their own tech stack, but the underlying video layer is built on top of us. So actually adding a security layer and keys, you can do that inside of Millicast so that a secure viewer is built for a particular viewer with a particular password. You can send invitations and so on and so forth. So as I scroll through this, here you see it's still a very beta product, but this allows you to produce the shots. So you can see here the shots that they've produced to add different guests into different views. So you have the master, who's the host, and then you can do that. You can do a 2-up display, you can do a 3-up display, so on and so forth. And I'm sure they'll improve the UI of this eventually as they go through this. And we used this particular tool to do the meeting this morning. And you can see he's doing a screen share, which is the master, and the quality. Look at this is superb. It's so much better than you can already do with Google Meets or with Zoom. And as we scroll through this, you see this is how you can control the teleprompter. You can control the provider. They're sending us to Millicast. They're choosing the actual source stream resolution. And that gives you a good idea of everything that can be done in that platform. So go check them out. Really cool product. I think for a lot of you, ultimately, Millicast is a platform as a service. That's not a fit for everyone who's on this call. Like a lot of the people on this call don't know how to use an API. They don't know how to build a white labeled product on top of us. And that's fine. And you can go and use Millicast for just what you see, what you get. Like I did the first demo I did at the beginning using the broadcaster and the player, having a hosted page and doing that for your customers or doing that for yourself. And that's a great use case for Millicast, and it's affordable and it's doable. Where Millicast really has its value is being a true platform as a service to do what StreamClick is doing. We also have another customer called setstream.io. And setstream is in that remote post-production space, and they've built this really great tool that allows you to do everything that I've talked about today for the remote production space. And what they do is they sell ticketing. So they pretty much give you, so if I go to the shop, you can buy a pass for different hours to go and use the entire platform for just an hour. You need to go post-produce something for an hour with all your colorists working on a movie. Boom, go to Setstream, buy it for an hour, use our product. They've built all the tools for it, and it allows them to do that. And we have quite a few other remote production use cases that do that as well. And so that's great. They can actually go after that production market. That's not what we're here for. We're here to actually enable the development of those SaaS products on top of our PaaS and our WebRTC CDN. So with a few minutes I have left, I just want to jump in and finish up what we've got here as far as slides. Some of the other use cases, I think probably the biggest one that's going to happen in the streaming industry, it already has started to happen. Look at Twitch. Like, what was Twitch? Twitch was a game streaming platform. Amazon bought them to go and get into that vertical market, right? And what they've been able to do with the Twitch's underlying tech is Amazon bought Elemental, launched Elemental Live and Elemental Cloud and all that. What they've been able to do with Twitch is go after a completely different market, which is, gamers and consumer grade streamers. And what better technology to hit that market with than WebRTC? It's free. Most gamers use OBS, so why not just use OBS with WebRTC, or why not use these workflows? And with gaming, it's high frame rate, right? It's high quality, it's high resolution. Oh my God, like all these other tools that are being used now to try to do that are an absolute nightmare when it comes to true game streaming and eSports and so on. Google Stadia has bet big on WebRTC. Obviously, WebRTC is a Google technology. A lot of their layers and the WebRTC functionality is already in there. How do you scale that? How do you, build the monitoring and the interactivity and the end-to-end media layer and all that, and the scaling layer to work with Google Stadia, right? And do that with game platforms. A more traditional kind of workflow with gaming is not new technologies that are embracing WebRTC already. It's also all the games that are already out there that are built on gaming engines. Unity and Unreal, two of the largest gaming engines in the world, they probably, their market share is just ridiculous. There's already use cases. Unity already has a WebRTC implementation. We're working with a VR and AR vendor. I think they're in Seattle. That has developed a game for surgeries. And it's not a game. What it is it's a real educational tool to teach people how to do surgeries in real time. And they're doing real-time streaming to medical universities around the world, not showing actual procedures, but showing virtual procedures through a VR AR headset, capturing the output inside of the gaming engine, sending it over WebRTC, and then scaling that to, thousands, tens of thousands, hundreds of thousands, millions of passive viewers around the world who get to see that in their own headsets or get to see that in browser. And that's a crazy use case, right? Like that was amazing. Telemedicine is also very much going to be used for this, right? From a diagnosis perspective, and it already is being used. We were doing a lot of that at Wowza, with WebRTC stuff. So the use cases for gaming are huge. The other really cool demo I want to show you guys is we have an implementation working with a DJI Mavic Mini. I think it's like $400, $350. You can buy them at Costco now and Best Buy and everywhere, right? If I pull up that video, I'm going to show you real quick what that implementation looked like. And this is one of our engineers worked on this implementation in his spare time. That's what I love about the streaming industry, is just playing with these cool tools, right? So what it is we got a stream from the DJI Drone.
PowerPoint has been updated.
And you can see as it was flying, it was communicating with the local device, right? With the Magic Mini, you have an encoder, a software encoder that sits on your mobile device. We were doing an RTMP ingest with this particular use case into Millicast, and then streaming, and then doing the conversion to WebRTC. But this is a great example of a product. Most of these devices have Android OS on them. We already have, you can use WebRTC with Android OS devices to do the encode directly on the device. So I think that's a very interesting use case for doing all kinds of drone footage. And I talked a lot about drones at the beginning. Like, just think of all the use cases where drones could be used for security and monitoring and reducing the expenses of at so many different levels, right? When it comes to commercial applications. And then I've talked a little bit about remote production. We've worked with BirdDog and the BirdDog Cloud. NBC and Prime Video did the AVP, which is a professional beach volleyball circuit, when they came back after COVID. There's a case study kind of talking about the details, and we have a tutorial video with how that worked with BirdDog. There was none of the producers were on site. They used these cameras remotely through PTZ, all remotely, to produce the shots. They monitored the shots in real time using Millicast, and they were able to mix in between those and produce a stream that was sent across NBC and Prime Video. So we're not talking about, very minor use cases here of some person you've never heard of. These are major brands that are using these technologies to do to mitigate and solve workflows that are needed right now, right? And NFL used us for the Super Bowl. Pacific Post is one of the biggest post-production houses in LA. They're a large customer, as well as Setstream that I referenced. And live auctions. We're working with Invaluable, one of the largest live auction providers in the world. They've started to use a lot of our architecture and migrating a lot of their tech stack to us to scale, and they've had really good results from it. We're working with Sotheby's and Interactivity, which is probably butchered that in French. They're the largest auction house in France. That's one of our longest customers, and they do hundreds, if not thousands, of streams weekly. And with that, because we're just about the top of the hour, guys, and I know people have been dropping off because it's been 3 hours of listening to me, which is unbearable. But I encourage you, go to millicast.com, sign in for free. It's a free forever account. It's 50 gigabits. If you want to get started, add a credit card, create a token, broadcast, playback, monitor, and manage. You can start playing with it all right now.
Excellent. Thanks so much, Ryan. Thanks everyone for attending. And we'll see you back for another virtual streaming media in May before we get back to Huntington Beach in October.
Thanks again. Bye, guys.
Bye.
Thanks for your time.